கேமரா முன்னாடி மூஞ்சி கடிச்சிட்டு இருக்காரு.
இவருக்கு கேட்கல இருமா பேசுமா
இல்ல சார் நீங்க பேசுறீங்க
நீங்களும் போக சார்
முருகேசன் சார்.
ஹலோ சார்.
சொல்லி ஓகே ஓகே
ஓகே சார்.
அவங்க உங்களுக்கு இது எம்ஓசி பண்ணும்போது தமிழ் தாய் வாழ்த்துன்னு கூப்பிடுவாங்க.
ஓகே சார்.
அப்ப நீங்க பண்ணிருங்க சரிங்களா?
ஓகே சார். ஓகே சார்.
ஓகே ஓகே தேங்க்யூ
சார். முருகேசன் சார்.
மனோஜ் சார்.
சார் முருகேசன் சார் ப்ளீஸ் என்னோட டிஸ்பிளே பண்ணுங்க எனக்கு. ஷோ மை டிஸ்பிளே ஐ கேன் செக் தட். முருகேசன் சார். I can't. Okay.
Dinesh Babu sir, are you present, sir?
Good. Yeah. Hello.
Okay, sir. Okay, sir. Fine.
Yeah. Yeah. So now only I joined. Hello.
Science knows no country because knowledge belongs to humanity and it's the torch which illuminates the world. A cheerful good morning to one and all present here. It's my privilege to be a moderator for this wonderful occasion. On behalf of PG and Research Department of Physics, it is my pleasure to extend a warm welcome to one and all for this international conference on Advanced Materials Science, ICAMS 2021. First and foremost, I would like to thank one and all for sparing your valuable time and being a part of this wonderful occasion amid your busy schedule, especially the chief guest, Dr. Dinesh Babu Velusamy from Cambridge. Thank you, sir, for spending your time with us. Prayer is the beginning of the ceremony. Let's have the prayer sung by invoking the muse. I welcome the students of the Vivekananda College of Arts and Science. There come 6 students to sing a Tamil song. Tamil Tagal.
நீராறும் கடலுடுத்த நிலமடந்தை கிளியுழுகும் சீராறும் வதனமென திகழ் பரத கண்டமிதில் தெக்கணமும் மதிச்சிறந்த திராவிடனல் திருநாடும் தக்க சிறு திரை நுதலும் தரிசனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழழங்கே தமிழழங்கே உன் சீரிழமை திறம் வியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
Thank you, students. Welcome is the way of greeting others, which shows the hospitality. Hospitality shows the humankind. Now, I would like to call upon our beloved principal, Dr. B.T. Suresh Kumar sir, to welcome the gathering.
The respected, the chief guest of the conference, Dinesh Babu Velusamy sir, respected our the director of academic affairs for the arts and languages, distinguished guests, deans of physics, organizing secretary, participants from various institutions, my dear faculty members, beloved students, it's a very warm good morning to one and all gathered here in a virtual conference. It is a great day to see the most eminent personalities in a single virtual platform. I'm very happy to welcome you all. And there is no word to share my incalculable pleasure to appear before the learned personalities on the virtual platform to give a warm welcome you all to this national level e-conference on advanced material science, ICAMS 2021. So in this juncture, I would like to share about the advanced material science. Material science is the interdisciplinary subject spanning the physics and chemistry of a matter, engineering application, and industrial manufacturing process. Modern society is heavily dependent on advanced materials, lightweight composite for the faster vehicles, optic fibers for the telecommunication, and silicon microchips for the information revolution. Material scientists study the relationship between the structure and the properties of the material and how it is made. They also develop the new materials and diverse process for manufacturing them. Material science is vital for developments of nanotechnology, quantum computing, and nuclear fusion, as well as medical technologies such as bone replacement materials, etc. For this, the few words, it's my bound duty to welcome for all for this international conferences. As a principal of the esteemed institution, first of all, I thank our beloved chairman, sir, who has showered us with his generosity and is always to noted his vision on the women empowerment and industrious workmanship on the welfare of the society. That's why we have such a biggest institution with all potential in an unimaginable village. I must thank him not only for this opportunity, but on behalf of the person with a social consciousness, on behalf of each and everyone, I welcome our beloved chairman and secretary, sir, in absence. I welcome our chairman, madam, though she is in absence here. As we know, there is a woman beyond every successful man. She is there and sends us the blessings and wishes for the great success of this conference. She is the lady who walks with our chairman, sir, and leads us to follow the head, not only for the official, but also the personality. On behalf of each and every one of them, I proudly welcome you, ma'am. On behalf of our institution, I'm very proud to welcome today a chief guest, Dr. Dinesh Babu Velusamy, Sir Cambridge Gramophone Center, the Engineering Department, the University of Cambridge, the United Kingdom. In spite of his busy schedule, Sir has accepted our invitation. Is being with us as a chief guest. Is going to deliver the inaugural address in this international conference on behalf of Vivekananda College of Arts and Science. Extend a warm welcome, you, sir. I have no doubt that is their vision and sense a purpose for the forms of the building block of our institution. There, the enthusiasm and contagious, and we cherish it. I use the golden opportunity to welcome our trust people who have been contributing their peerless effort to the development of our institution. We miss among us our most respected, our joint managing director, Dr. S. Arthanadiswaran, sir, the most respected, our joint secretary, Dr. K. Raganidhi Arthanadiswaran, ma'am, most respected, our vice chairman, Dr. K. Kribanidhi, sir, most respected, our director, ma'am, Dr. Nivedana Kribanidhi, ma'am, who are all very supportive for this international conference, who are not able to present here with us today to another engagement, I am very proud to welcome you all for this wonderful conference. Next, I extend a warm welcome our most respected Executive Director, Dr. K. Kupusamy sir, the man who's guided us in a profound and development of our institution in each and every step of our development of the institution, sir always to help for us. So on behalf of the organizing committee, on behalf of Ananda College of Arts and Science, I extend you warm welcome you, sir. Next, I use the great opportunity respected the Director of Affairs, Dr. V. Kumaravel, who is continuously giving his knowledge and experience and efforts to building of the institution, a remarkable status of our chairman, sir, vision. I welcome you, sir. On behalf of such a big institution, I welcome and you get an institution to glorify itself by your valuable present and presentation. I assure that opportunity is one for remarkable milestone in our institution, the history, where these experts who came from all sides of the country with a prolonged education and knowledge of history to make the step ahead. I welcome you all once again for accepting invitation and present here. Next, I extend a warm welcome our the Dean of the Physics, Dr. Gondipan sir, is always to support for organizing this wonderful conference. I welcome you, sir. Next, I extend a warm welcome. That's organizing secretary, Mr. Ramesh, is always to take an earnest effort for the past 2 months. I extend a warm welcome, sir. Next, I extend a warm welcome all the faculty members of the Department of Physics. Just had to render my sincere effort for the past 2 months. I extend a warm welcome all of you there. Last not but the least, how can to forget? I welcome the princess of this occasion. You are the bona fide of this national conference. I serve my welcome all my dear students of our institution, our guest institution. I also take this great opportunity to welcome members, the distinguished guests, and all the participants from the various institutions. Once again, I welcome you all for this the wonderful e-conference is advanced material science. So once again, I'll welcome you all for this wonderful conference. Thank you very much.
Thank you, sir, for your lovable welcome address. Science is a promise. Science is a souvenir. Once given, never forgotten. Never let it disappear. It's a time for souvenir release. May I request the honorable dignitaries of Vivekananda College of Education, Professor Dr. S. Kupusamy sir, Executive Director of Vivekananda Educational Institutions, Dr. P.T. Suresh Kumar sir, Principal of Vivekananda College of Arts and Sciences for Women, Director Academic, Dr. V. Kumaravel sir, to release the souvenir. It's a time for souvenir release. I request the department faculty members and the dignitaries to release the souvenir.
That's done.
The articles has been written by experts, scholars, professors from various places, various universities. We are very happy to introduce the souvenir. The souvenir is not like a book. It's a kind of knowledge. The book full of contains the advanced material sciences. Thank you, sir. Thank you for releasing the seminar. Thank you so much. Now, I would like to call upon Professor Dr. S. Kuppeswamy, sir, to deliver presidential address.
Good morning to all of you. Am I audible?
Yes, sir. It's
Yes,
audible,
sir.
sir.
Yes, you are audible, sir.
Okay. Thank you. Thank you so much. Good morning to everybody. The resource person of today's morning session, Dr. Dinesh Babu Velusamy, the principal of the Vivekananda College of Arts and Science, Dr. Suresh Kumar, the Dean of the Dean of Physics, the head of the Department of Physics, the Director Academics of Arts and Science Colleges, Dr. Kumarave, the faculty members, the participants of this international conference on, the international e-conference on the, a latest topic of advanced material science. Ladies and gentlemen, it's indeed a pleasure for me to be associated with the inaugural function of this e-conference that is being conducted by the Physics Department of the Arts and Science College of ours. I think the principal has given a short view of what is all about the conference. I'm really happy looking at what is really happening in the science and technology in the last 50 years. When we just roll back and find out there are lots and lots of things that have happened, and we are enjoying the fruits of all these research that have been done by various sectors of the people, particularly the scientific community and then the engineering and technology community. Just roll back, maybe in the 80s and 19th century and 20th century, we always called that as an industrial revolution. Well, the industrial revolution was there, then subsequently it was automobile revolution. Of course, everything continues to happen. And subsequently what has happened is that, from the industrial revolution, we have gone into the information or the computer revolution, electronics and communication and things like that. Subsequently, it has led to the information revolution, which has led to the knowledge revolution. And today, the whole industry sector or the entire population of the whole world are looking at a different revolutionary sectors. And that is what we are calling it as an industry 4.0. Either it is of science or it is of manufacturing industry or it is a service industry, whatever it may be. We talk of the 4.0 level. Even in education, we talk of education 4.0. This is simply because the change that has happened over the last 100 years is enormous. What we have seen on those days in the 20th century is no longer true today. Everything has changed. For example, today we are able to conduct a conference, an international conference, via the electronic means, which we would have never imagined in the early days. Why I am just saying this is that the change that has happened in our life from what we have seen it in our younger age till today, the transformation that has taken place is all due to the inventions. Particularly, these inventions have been supported by the development in the material science. See, the whole, gamut of electronics and then your computer science, everything has been triggered by the introduction of the silicon. Of course, in the initial phases, we had germanium. With the germanium, we were able to construct transistors and so on. But after introducing the silicon, the whole thing, the concept has changed. We have started using that in different dimensions, packaging density and things like that. Then, of course, the research have started looking at in different dimensions of the material science. Of course, most of you may not really relish whether this material science is being used in all applications. It's really, it is true. You name any discipline in which the material science is taking a big role. Let me take, for all of us, dwelling is an important part. You know, we need to have a place to stay back. To comfortably protect ourselves from the natural environment hazards and things like that. That means a residential place and then an office place and so on. We need to construct buildings. Of course, in the olden days, the buildings were of different types, were constructed either by use of the wood and maybe the mud and so on. The concrete technology came into being, and today we are talking of nanotechnology in the construction. The architects are in a position to design wonderful buildings, a sky-rise building and so on. All that are possible because of the developments in the material technology. And today people are talking of self-healing concrete. That means, like, you know, if something is broken, what you do, you get a quick fix and then you try to fix it. Earlier days, we have to wait for at least 8 hours before it gets healed up. But today you have the liquids that heals within few seconds. The moment you fix it, then it is all, and you cannot even break it. The strength of the bonding is so high. Similarly, in the concrete also, people have thought and then they have brought in a concept of self-healing concretes. These are all the innovations in material science. Similarly, the nanotechnology, I think the principal also mentioned that the direction in which it goes. The nanotechnology is the one which has invaded almost entire scientific world and also the engineering and technology world. And coming to the present condition, because I don't want to take much of your time, we are talking of autonomous systems. Either it is in the manufacturing industry or it is of the day-to-day of our lifestyle or whatever it may be. We wanted to see that everything is controlled by a small device that you hold it. That small device now today is your mobile phone. It's much powerful than that of the computer that I used in my study days. At least, I don't know, 100 times powerful than that of the computers. And using that device, you will be able to control all your activities of the day wherever you are. It's immaterial. If you're a farmer, your irrigation can be carried out using your mobile phone. If you are an entrepreneur, if you have your industry, you can even monitor and then give instructions sitting at remote. You need not be in the same place in the industry. You can be far off, maybe you can be traveling abroad, but still you can monitor. The sensors have become very, very important component today, which feeds the information and then to your convenience and you will be able to make use of it. How these sensors have come into being, it's all the evolution or the developments of the material science. The sensors are playing a vital role in the autonomous systems of anything you talk of. Either it may be a car, or it may be a robot, or it may be something that you would like to conceive in the industry. Now we use an IoT, Internet of Things, and with the sensor, and you are able to manipulate. The people have started developing automobiles which can run on its own. You need not even have a driver. You can, I mean, if you are talking of Uber or whatever they call taxis, you can book it, and then without a driver, it can come to your place, it can pick you up and drop you in your place. And it drives on its own. Today, if you order in Amazon and Flipkart, things are happening. I mean, somebody comes and delivers to you. Maybe 10 years down the line, there will not be any delivery boy. Even if you order for about, food in Swiggy, you will get it delivered in your doorsteps on a fixed time without any problem. That means the drones, autonomous drones, are going to take over. It's not long, it's maybe 10 years down the line. We people are going to enjoy the fruits. All these things have happened because of the developments in the material science, and that we have to take into account. I'm really happy that the Department of Physics of the Vivekananda College of Arts and Science has thought of the very, very important topic for this conference, and they are conducting it in a very big manner, inviting the resource persons from various other countries. Today, the key speaker is from Cambridge University from the United Kingdom, and he is able to join with us. On behalf of the management and on my own behalf, I extend a very warm welcome to him. I also extend a very warm welcome to all the participants who thought this institute can conduct a quality conference, and then there will be a takeaway at the end of the conference. I think we always need a food for thought, and that is what we are trying to give you here through this conference. And of course, I'm sure those who are really interested in pursuing the research and taking up a research activity, this conference will kindle a fire in their mind and also give some lead for them to take up the research activity. I wish them all, and I hope the conference will go in a very big way to inculcate the research activity in the young minds of all the researchers who have assembled today. I take this opportunity to wish the organizers for their hard work, and definitely the conference is going to see its success. So you should continue such activities in the days to come also. Let me wish you all the best, and thank you very much for the opportunity. Thank you so much.
Thank you so much, sir, for your fabulous address. We have happy news. We have a new guest, Dr. Jayaramakrishnan Veluchami, Mary Curie Fellow from Cambridge. I'm very happy to welcome Dr. Jayaramakrishnan Veluchami. And next, I would like to call upon Dr. V. Kumaravel sir, Director Academic of Vivekananda College of Arts and Sciences for Women, to felicitate the gathering.
Yeah, very good morning to all of you. So is this audible?
Yeah, yes.
Good morning, sir. I am very happy to take part in this international e-conference on advanced material science. Today we have the chief guest from various renowned and popular universities from UK, Japan. So especially our resource person, Dr. Dinesh Babu Veluswamy, Dr. Jayaramakrishnan from University of Cambridge, UK, and Dr. Sekhar Karthikeyan, University of Tokyo, Japan, and Dr. B. Yalil Selvi, National Physical Laboratory, New Delhi, and many more people, those who are going to share their experience and recent developments in advanced material science to our students. See, I really congratulate and appreciate the organizer for selecting this wonderful topic, advanced material science. So when we talk about material science, the developments, everything, it was happened in very olden periods also, especially in India. Our archaeological survey reported that our ancient peoples of India, they were well versed with material science even in the ancient days. See, the archaeological survey from Harappa and Mohenjo-daro and even in Tamil Nadu, Keeladi, it proved that many materials and equipments were designed excellent way in the olden period also. So from this we can able to understand our ancient people were having excellent knowledge in material science, how it can be used for their day-to-day life. See, even today also, it has a lot of research potential. In future, it is focused on material design, computational material science, advanced analytical methods, and manufacturing and processing of nano smart and biometric materials are having a huge research potential in this material science area. So I request the participants, you can have very good conference today. So you have to make use of this conference. You can interact with our resource person. You can update your knowledge in excellent way. So I thank the organizer for giving me this wonderful opportunity. Thank you. Thank you. I wish you all the best. Thank you.
Thank you so much, sir, for giving a wonderful felicitation address. Now, I request Dr. K. Ravikumar to introduce our honorable chief guest.
Good morning to one and all present here in this great occasion. It's my privilege to introduce Dr. Dinesh Babu Veluchami in this inaugural function of this international conference. Dr. Dinesh Babu Veluchami currently working as a senior research associate and a teaching fellow in University of Cambridge, UK. Also, he recently got a Marie Curie fellowship with Nobel lecturer Sir Andrew Gem, University of Manchester, UK, with approximately 2.2 crore funding. Previously, he was a postdoctoral fellow in King Abdullah University of Science and Technology, Saudi Arabia. He completed his PhD in material science in Yonsei University, South Korea, with a highly competitive international scholarship. He has a strong science and engineering background, and his fast research direction and as well as current research program are highly and multidisciplinary in nature. He has over 10 years of research experience in studying the process and structure and the property relationship of nanomaterials. In particular, he extensively worked on the functionalization of two-dimensional materials such as graphene, transition metal, dialkogenides and maxons with self-organizing polymer systems. Further, he developed thin nanohybrid thin film electronic devices, including flexible broadband photodetectors, non-volatile resistive memory, ferroelectronic memory, and the energy storage devices. Dr. Dinesh Babu Veluchami has published over 20 research articles in high-impact essay journals, including Nature Communication, Advanced Materials, Advanced Functional Materials, Nanolattice, and Advanced Energy Materials. Also, he has an award of 1 Korean and 3 USA patents. He is the member of Royal Society of Chemistry, and his many research works are presented in international conference and got attention from peers and medias and industries. Thank you for this great opportunity. Thank you.
Thank you, sir. Thank you for the introduction. Now, I would like to welcome our distinguished chief guest, Dr. Dinesh Babu Veluchami from Cambridge University to start his lesson.
Good morning to everyone. So, are you able to hear me? Hello. Hello. Am I audible?
Sir, yes, sir. Yes, sir.
Okay.
Audible, sir.
Okay. Thank you. Good morning to everyone. Thank you so much for giving this opportunity to present all of you for the young minds. So, in particular, I would like to thank the principal B.T. Selvakumar, Dr. B.T. Selvakumar, and Professor Dr. S. Kuppusamy, Executive Director of EI. In particular, he gave the excellent introduction about the material science from germanium to silicon and nanomaterials and the self-healing materials. I would like to appreciate that. And the Director Academic Kumaravel and the Head of the Department Physics, Dr. Ramesh, and Dr. K. Ravi Kumar for nice introduction. Thank you. Thank you for everyone. So I would like to start my presentation. So I will share my screen. So are you able to see my screen? Yeah.
Yes, sir.
Okay. So today I'm going to discuss about the solution processable 2D materials for thin film, opto, and electronic applications. So this only I will take these two applications. So in this talk, I briefly introduce about the 2D materials and their functionalization with polymers. In particular, 2 examples or 3 examples if time allows, and their thin composite film applications for 2 applications. One is non-volatile memory, another one is flexible broadband photodetectors. So actually, Dr. Ravi Kumar gave a very good, nice introduction about me. So I briefly tell you. So I did my BSc and MSc chemistry in Government Arts College under Bardiyar University. Then I moved to Anna University for the MTech Polymer Science and Engineering. So I have the science and engineering background. This motivated me to move PhD in Material Science and Engineering and Yonsei University. So one of the top university in South Korea. Then I'm working as a postdoc in up to 2019 in King Abdullah University, Saudi Arabia. I mainly focus on 2D materials for electronic and energy applications. Then currently I'm working as a senior research associate and teaching fellow in Cambridge Graphene Center with Professor Andrea C. Ferrari. It's a solution process 2D materials for energy storage and optoelectronic application. As well as I'm giving the lectures to the MRes course students and supervising graduate students. In this background, I have worked last 10 years for the layered materials. Layered materials are nothing but it's a van der Waals solids which have the strong interaction between the in plane, but on the on plane, they are weakly attracted with the van der Waals force. When we give the shear force, we can easily exfoliate these sheets. So these sheets give the showing the very good performance and properties. For example, the well-known example is the graphite. The 3D nature is graphite. When we exfoliate this material, it will give the graphene. Graphene is well known. Its research is going on last 15 years. In 2010, Professor Andre Geim got the Nobel Prize for the groundbreaking experiments in this material. So this material, so just assume the bread is the whole bread. So the whole bread is a 3D nature. But when we make the slice, it's a 2D. Assume like that. So in the whole bread, we cannot, the surface area and the usage is less. But when we make the slice, it will give the more surface area. We can use more place to apply the jam or butter, like that things. So we can use for several applications. We can for the several area we will get. So not only the graphene. So graphene, for example, it's we have the zero band gap material. We know the semiconductor material or conducting material based on insulating material based on band gap. But in particular, the graphene is a zero band gap. It's a semi-metal, and also its mobility is very high, and also conductivity very high, and it's giving the mechanical strength more than steel and very good strength. So it's but very thin. It's in the nanometer, 1 nanometer thickness. So it's very good for various applications. Not only the graphene, later people researched for various materials like for transfer metal dichalcogenides, TMDs. TMDs from various TMDs, so it's available. MOS2 is a well-known researched material. In different from graphene, TMDs are direct band gap materials. Its mobility is high. It's showing the strong photoillumination properties. And when we make the transistor, it will give the high on-off ratio. So that one is very good for the amplifying, and with less number of transistors, we can achieve the properties. So this is not only the two family or one family, it's very big family, and lot of materials available in this family, 2D material family. So from graphene and boron nitride and graphene oxide is another well-known studied material, and transition metal dichalcogenides and semiconducting dichalcogenides. Several materials are available. And recently people start to research on 2D oxides like moly oxide and vanadium oxide. These materials previously used for various insulating and semiconducting materials for a long time, but now it's in 3D form, but now it's in 2D form. And recently the perovskites, well-known material for the solar cells, people started to use this one in the 2D for various applications. So application sense. So from due to their its enduring properties and very good physical nature and less weight, it's used from and high aspect ratio. These materials used for various applications, from automobile composites to electronic applications like transistors and sensor, biological, chemical, and electrical sensors, and energy storage conversion. It's in particular, it's in the battery and supercapacitor and biosensing, environmental barrier and production. In particular, when I worked in Korea, so the LG people, LG company, LG Display, they started to use for the touch screen panel application. And it's not on various applications, almost all applications from electronics to biological applications. These 2D materials are used, and there is a lot of room to work on these materials for find various applications. However, 2D material science is exciting, but properties are versatile, remarkable. But to make the potential implementation, to make in the commercialization these materials, scalable production methods are needed. Now it's people are making, very few companies are making in the gram scale level per day, but that is compared to their performance, it's not enough. So we need to make the scalable production method and technologically viable deposition method on various substrates. For example, when we use the silicon substrate or flexible substrate, we need to deposit. We cannot use the same method to deposit these materials on the substrate. So we need to find the technologically viable deposition method. And over deposition areas, now people are using very small area. It's a maximum, it's 3 into 3 inch. That is not enough for our need. We need to make the large display at least 20 centimeters, 20 inch or 50 inch. That is very important. So we need to control the deposition areas and substrates. As I said earlier, it's not only the rigid substrates. We need to make on the flexible and stretchable substrates, and in collaboration with other materials. The best example is polymer composites. When we mix with the polymers, we can improve the many properties, and we can not only improve in the properties, but also we can add giving the additional properties to the material. So for that, these things we need to, these are challenging. People are addressing these challenges. Among the various preparation methods for so far the 2D materials, the first started method is mechanical exfoliation. It's simple. When we take the graphite as a 3D material, by using the scotch or sticky tape to attach and remove these seeds from bulk to making it by exfoliating several times, so we can make it the single layer. So this one is first published in 2015 by Professor Andre Gein group. So then after that, it's a growth on various substrates. So growth means by using the chemical vapor deposition or physical vapor deposition like that materials people use it to growth by giving the source material heating, it's vaporize and deposit on the substrate. So here we can use only the rigid substrate. And another method is the liquid exfoliation. So in this case, we can put the starting material, bulk material in the desired liquid, and we can, by applying the ultrasound or shear force or electrochemically, we can exfoliate this thing in the liquid. Here you can see the summary of the various methods and their quality, material quality, and the price, low production costs, mass production costs. So when we make the Scotch tape exfoliation, the quality is very high, but price it's very high. So we need to spend a lot of money and a lot of time. So it's not usable for the commercialization, but it's very good for the research and also the CVD or the assembly, molecular assembly. Among these all available methods so far, liquid phase exfoliation is much better. Why? It's because it will give them, we can make the easily coat on various substrate as a ink, and we can incorporate with other material to form the composites and the energy storage and the transparent conductive layers. For these kind of application we can easily use, because liquid phase exfoliation is a cheap price wise. So quality we are compromising a little bit, but we can use, and several people used for several applications, many applications. In the liquid phase exfoliation layer methods, generally two things are there. One is by using the lithium intercalation. So when we are taking the 3D layer and we put the lithium or lithium similar materials and intercalate with these things, this is the 3D sheets. So it will, when we apply the shear force, it will exfoliate. So we can use. Another one is the sonication or shear, applying the shear force. We when apply without any lithium, it will because of the weak van der Waals interaction, it will easily we can peel off. So when it's used a good solvent, it will again not restack, so we can get the 2D sheets. However, so far it's insoluble or poor dispersion in, never it's not soluble. It will give the poor dispersion in organic solvents, and also difficult to make thin films and composites with other materials due to incompatibility of the solvents. So majority of liquid phase exfoliant for the MOS2 are like TMDs and graphene. People used the NMP, N-methylpyrrolidone, or water. These are the best solvents. However, these solvents boiling points are very high. For example, NMP boiling point is 235 degrees Celsius, which is not suitable for many applications because the material or substrate will spoil, damaged with this high temperature, and removing all solvents is almost impossible. So alternative solvents, in particular non-polar solvents, are very good, such as toluene, benzene, for the industrial applications. So based on these things, further functionalization of these materials is necessary to use for various applications. So compared to other dimensions, 1D, for example, the carbon nanotubes, or 0D, like nanoparticles, silver nanoparticle, iron nanoparticle, RSI nanoparticles. The 2D materials have the strong aggregation force due to the surface area size and aspect ratio. It have the strong aggregation tendency. So we need to, for make the liquid phase exfoliation or in the liquid formation, we need to remove this aggregation tendency. We reduce the aggregation tendency, and large quantity of these materials without disturbing the structural integrity and without damaging the property, we need to make these materials. So functionalization is important. So in the last 10 years, I worked on these issues to solve these issues. So I developed the effective functionalization methods to make the 2D materials with self-assembled polymers and individually dispersed polymers for thin film electronic applications, which is comparable for the other CVD and mechanical exfoliated Scotch tape method materials. I use the controlled non-destructive interactions and simple thin film fabrications to make these things. I will show some examples. So I use the surface functionalization of 2D materials. For example, I use the graphene, reduced graphene oxide. as well as for the TMDs. First of all, in 2012, I published this work. It's a functionalization of 2D graphene, reduced graphene oxide by using the polystyrene block polyparaphenylene polymer. This is called block copolymer. So because the two blocks are there, one is the polystyrene block, another one is the paraphenylene block. In this material, when I take the graphene oxide and I convert into by using hydrogen peroxide, I use the reduced graphene oxide, I convert. Then I mixed with the polystyrene block polyparaphenylene polymer. I modified this one. So here you can see the filtered RGO films. This one is the vacuum filtrated film. So this one gives the high conductivity. So what's the mechanism behind this? The main thing is the strong 5-5 interaction between the base plane of the RGO carbon plane and polyparaphenylene block. It will form the 5. So 5 group in the polyparaphenylene, so and 5 group in the graphene, reduced graphene oxide, make the 5-5 interaction. While the polystyrene block will provide the very good solubility, dispersibility in the various non-polar solvents like toluene. So here I used several solvents like industrially relevant solvents like THF, which is highly used in the industry, THF and toluene, and acetone low boiling point solvent, and benzene again non-polar solvent, and methyl ethyl ketone. Like these solvents, I used several solvents. Here is a few examples. When I used this polymer functionalization strategy, so it will give the high dispersion RGS concentration in up to 1.5 mg per ml, which is it's high dispersion in the time in this non-polar solvents. Now it's around people able to disperse around 3 mg per ml. So with very less polymer, it's a polymer I used only 1.8 mg per ml. So this one is very good. Still, it's a best result with low content of polymer to disperse these materials. Because when we use the more polymers, so it will reduce the properties of the graphene, because inside the composite, its graphene content is low. The main reason, so we look for the reason, so why it's giving the dispersion by using only this kind of polymers. Then we go to the solubility parameters. Like here we use the Hansen solubility parameter to derive. So there are solubility parameters, three parameters are there. One is the dispersive, another one is polar, and hydrogen bonding components in the Hansen solubility parameter. These components are there. So when the hydrogen and polar components match with the RGO concentration, it will give the very good dispersion. So for example, so THF give the very good high concentration dispersion, because the sum of Hansen hydrogen bonding and polar solubility parameter components, when is near to all or near, so that one give the very good dispersion. And here you can see, so this one of the AFM image of the RGOs, reduced graphene oxides, and this one is the functionalized. The right hand side is the functionalized reduced graphene oxides. Here, so without functionalization, it's to give the lateral dimension 500 nanometer. Thickness is about 0.8 nanometer, which is actual thickness of this single layer sheet. When I do the functionalization, the thickness is increases. It's around 2 nanometer, because the both sides of the RGO, so then the top and bottom, the polymer is covered like sandwich. So this one is the main reason for the giving the good dispersion and solubility in various non-polar solvents. And I'm able to coat this material in the large substrates, a large area, and various substrates. For example, from glass is highly hydrophobic substrate, and silicon wafer, SiO2 wafer, and PET substrate, and even I can able to coat in the aluminum substrate. So this one is very good one. We used this strategy to file a Korean patent. And next is the functionalization of TMDs, modification of TMDs with the end functionalized polymers. So after my work in the RGO, so I moved to the TMDs, transition metal dichalcogenides. So in the TMDs, various TMDs I took, for example, MOS2, WS2, MOSE2, and all these things, and functionalized with end functionalized polymers. Means in the polymer chain, you had the only one end, one functional group attached. So this functional group will interact with the central metal atom of the TMDs. For example, in the MOS2, it will interact with the central metal MO, while the polymer chain will give the good solubility and dispersion. So the interaction is given on the Lewis acid-base interaction. So it's called Lewis acid-base interaction. In this interaction, it will make the not the strong bond. It won't form the strong bond like covalent bonding. It will just the interaction. So it won't affect the integrity or the internal properties of these any materials. So for this case, we have used several TMDs and several N-functionalized polymers like rigid polymer polystyrene, and polyethylene glycol is a water-soluble polymer, and polybutadiene is a rubbery elastomeric polymer, and polystyrene block isoprene is a black copolymer with a rigid and rubbery polymer. So like several polymers, I checked this one. The strategy is simple. So here I put the bulk materials and sonicate in the solvent with polymer. I can get the dispersion. So here, for example, you can see clearly the toluene is the only polymer. Only polymer. When I put the sonicate this material, it won't give the any dispersion. And also I tried with the only without the end functional group, only the polymer polystyrene. It will not give. It won't give the dispersion. When I use the amine terminated polymer, it gave a very good dispersion in toluene. So this one is proved. And I checked these material properties. So when without I use the amine terminated polymer, it won't give the any dispersion. So the 3D peak is still remaining very sharp. When I applied the amine terminated polymer and sonicated, the 2D peak is dispersed and the peak is moved. So this is one indication for the good dispersion. And also the UV absorption spectrum, yes, it's a semiconductor material. It will give the distinctive peak for the MOSE2 at 800 nanometer wavelength. So this one is again the proving that our strategy is working very good. And I optimized this process with various sonication time. It's 60 minutes. It's a low time. We can sonicate, and centrifugation. It's 1,500 RPM. And in particular, the polymer molecular weight also very important. So when we use the high molecular weight polymer like 100 or 40K, it will give the very less dispersion because the polymer, so when increase the molecular weight, the polymer chains are high. So the polymer entanglement is very high. So it's very difficult to disperse or separate in the polymer solution. When we use the low molecular weight, 9.5K or 25K, so it's giving very good dispersion. And with our simulation group, collaboration with our simulation groups, we simulated this, how the dispersion is working. So for example, so this one is the only polystyrene without the amine functional group. So here you can see in the dark ones are the toluene molecules, the brown one is the polymer chain, and the bottom is the 2D layer. When we simulate these things without any amine group, it won't give any interaction. But when we put the amine group, so here the blue one is the amine group, within several seconds, within few seconds, it start to interact. You can clearly see it start to interact with the material. So that is the main reason we are getting the good dispersion. And we checked this polymer dispersion in several solvents. It's like a benzene to xylene. So from various around 10 to 15 solvents. So these materials give the very good dispersion in various solvents by increasing the polymer concentration. The dispersion also increasing, and we got around 1.5 mg per ml dispersion, and yield is 10% compared to the starting material. We are getting 10% of dispersed materials. And in particular, so these materials are stable over 3 weeks. So this one is very good enough time to process this material for other materials, other composites, other polymer composites, and making thin films and for many applications. So this time is well enough. And again, the morphology. So although it's a solution process, so this one is the bulk material A. So B, when we exfoliate this material with polymer, it's the lateral dimension is decreasing, and as well as thickness is decreasing. The thickness is around 2 nanometer. So we check by changing the centrifugation rate, we are getting the layer thickness 1 to 3 layers. We have around 70%. We got the 1 to 3 layer thickness, which one is very good result. And in particular, so although it's a solution process method, we are using the mechanical shear forces after exfoliation. It gave the single crystalline nature, which one is important for the electronic application. So here you can see by using the HRTEM, we can clearly see the hexagonal structures of these 2D materials. So here also, you see in various places, we checked in the large seed, although it's a mechanical exfoliated in the solution process, it giving the single crystalline nature. And this one is not for the one material and one polymer, it's for generalized strategy. We used to check the several TMDs from MOS to WS to RESC to zirconium telluride and niobium selenide. So this one is the blank solvent. So this one is the Brownian movement. When we apply the light on the just solvent or one solvent, it's a light won't give the change the path. So we cannot see the light path, but there is a solution. If there is another material dispersed in that solvent, we can see the light path dispersion. So, and these are the results. So not only the several materials, we used several polymers, as I said earlier, to check these things with the several solvents. So these are more generalized strategy. These are the example images of these. Right hand side are the bulk materials, left hand sides are the exfoliated materials. Here you can see the in a scale bar. These are the micrometers, and when we exfoliate process, this material become the nanoscale level. And I can able to make this one in the liter scale per day. For example, I made these two materials, MOS2 and MOS2, 2 liter. This one is the 2 liter bottle. Per day, we can able to make in 8 hours, 2 liters. So this one is very good for the compatible with the industry applications. The another one, so which one is not possible for the mechanical exfoliation or CVD process, is the hybridization of 2D materials. To demonstrate this, I use the 2D organic material called graphitic carbon nitride and the inorganic 2D material MOS2. I processed in the solution. I took the bulk graphitic carbon nitride and bulk MOS2 and exfoliate in the same solvent called NMP, then hybrid these two materials, then make the devices. I will come this one later. So this one we can tune. So when we can use the same orthogonal solvent for the 2D materials, or any other material, we can mix and play tailor-made for the applications. So I mixed various concentration. For example, 10 here is the graphitic carbon nitride and 0 is the MOS2. So you can see the clear difference when we are changing the concentration, and I made the thin film for the applications. And I checked this mixing. Is it uniform or homogeneous or heterogeneous? I used the EDX mapping. In the EDX mapping, so this one is the graphitic carbon nitride and this one is the MOS2. So we can see the clear difference when we increasing the MOS2 concentration, MOS2 is increasing. Here also you can see, so this is the carbon around 0.5 carbon nitrogen peak and 2.5 M1 sulfur peak. When in the graphitic carbon nitride 10% without the MOS2, the carbon nitrogen concentration is high. While adding the MOS2, it's increasing uniformly. So here the only MOS2. So in the solution process, the functionalized stage. These material easily we can mix and play with these materials. We can tune the properties for the desired applications. Yeah, here you can see the hybrid properties. So here is the black one is the 10% of graphic carbon nitride. There is no MOS2 peak. When I increasing the MOS2, we can see the clearly, we can see the MOS2 peak at around 670. So these are the extracted data from these things. While in this one is the graphic carbon nitride. While increasing the MOS2, graphic carbon nitride peak is suppressed. So with these things, we can clearly tune the optical properties of this material. So these are the absorption. Here the graphic carbon nitride and MOS2. And also when we see the XRD, so the bulk MOS2 strong 3D peak and bulk graphic nitride strong 3D peak. When I make the hybrid, it's giving this one is the exfoliated 2D MOS2 and this one is the 2D graphic carbon nitride. This one is the hybrid of the MOS2 and graphic carbon nitride. So it's clear that it's exfoliated well and mixed well. So based on this background, so I prepared the hybrid materials. Prepared the functionalized 2D materials. I utilized these materials by making the thin films for application. One is the non-volatile memory, another one is the flexible broadband photodetectors. So the non-volatile memories, in particular ferroelectric field effect transistors, widely used for our RAM or ROM, these kind of phone, ROM or RAM. So these memories are used. So non-volatile means when even the switch off our devices, the memory is on. For example, when you use the computer, so without the power you cannot do anything. But when we are going to the phone or in the laptop, we can without the power also we can store these data. So this one called the non-volatile memory. Without power, we can still store these data. So here I use the prepared polymer functionalized graphene as the interlayer in the ferroelectric field effect transistor memory. Here the substrate. That's I use the flexible substrate for the demonstration. And this one is the gate electrode. Here we use the aluminum. And this one is an interlayer. And semiconductor layer active channel. And source and drain. Source and drain as the contact. So we use the different quantity of the reduced graphene oxide layer. And here you see the performance. So when I use without the polymer modified reduced graphene oxide PMRGO, the performance is poor. So when we applied the gate voltage higher than 20 volt, its device start to breaking. And also the gate leakage is very high. So at 30 voltage, its gate leakage is 30 nanoampere, which one is not suitable for devices. And when you use the one layer of PMRGO and two layer PMRGO, here you can see we can go to up to high gate voltage up to 50 volt. And also the memory window is this one important to store the data. Memory window also it's high. And also we reduce the gate leakage from 300 to 50 nanoampere. It's around 6 times lower. So this is mainly due to the RGO generated the localized electric field. So which one is preventing the gate leakage in between the individual RGO plane. This is the main reason for the good performance. And also I use the resistive memory. So here when we make this apply the electric field, the electron trapped in between the active layer. This one called one type of resistive memory. In this case, I use the PMRG as the active layer. This one is the device structure, the substrate and top and bottom two different electrodes, and we can coat the in between as the active layer. And also I'm able to make, I made non-volatile memory with the gold nanoparticle and GO composite, and also RGO positive and negative layer by layer coating. I make in the positive and negative layer solution and make the layer by layer. So this one is give the very good non-volatile memory properties. So here you can see the properties. So without here, so these are the only polymer. This one is with a low weight percentage of RGO. So it's not showing any memory properties. When we put the 2 weight percentage RGO, it's showing the memory properties. See, so this one is the circle memory, butterfly type curve we will get. So here is the lower current. And when we apply it's up to in particular voltage, it will give the higher current. So the memory window, we called this one is the memory window at the low voltage near 0. It's around 7 order. So this one is very high for the memory properties. So, and when we increase the more than 3 weight percentage, it's give the due to the high current, it will give the leakage and the device is broken. So this one mainly, so due to the voltage dependent, the electron trapping and detrapping. So when we apply the voltage, the electron is trapped. When we remove the voltage, its electron is detrapping. This one happening in between interface between the RGO and polymer. This is the main reason for the memory properties. And so these memories, it's very important is the retention, memory with retention and the endurance. Retention means how long this memory is stable. So we checked this one for up to 10 power 4 seconds. This one is similar to 10,000 hours. This one is very high in that time. So this one is a very good memory property. And the endurance, how many cycles we can on and off, how many cycles on and off. So here the endurance cycle is 40. So this one is relatively low due to the optimization issues. We worked later and we changed this performance. And next one is the band selective photodetectors. The photodetectors are very important for several industrial applications, and for example, and also in our photo camera and flash, and for these all these things, photodetectors are very important. So after preparing these TMDs, I'm interested in the flexible devices. So I start to make the flexible devices. In this case, so this one is the filter paper, generally in the laboratory using filter paper. I pour this solution on the filter paper and filter. This one is the active layer, the TMD layer. And on the top, I deposit the gold electrodes for the contact. See here, this one is the total, the devices. This one is the 25 centimeter, sorry, 2.5 inch filter paper, diameter filter paper, very small. And here we can make around 400 devices. So this one, these 2 electrode is one device, and these 2 electrode is one device. So we can make the contact depend upon the electrode position, the channel length and width is changing. That's all. So in the very small area, I'm able to make several few hundred devices in that small area. This one is the top of the layer, active layer, MOS2 layer, and this one is the cross section. So I can make it the 1 micrometer thickness or 1.5 micrometer thickness device on the filter paper. So it's highly flexible. And here the device performance, generally we know that the dark current, the black one is the dark current, and when we apply the light, the resistance current will change. So this one called the photodetector. When we apply the light intensity increasing, the current also, the response also increases. I can make the up to 5 order on-off ratio devices. When the on-off ratio is high, the device performance is good. On-off ratio high, around 5 order. The mechanism is simple. So since the semiconductor material, so when we, this is the normal state, this one is the, in the bottom is the applied light. When we apply the light, when we applied the light, the photons generate the charge carriers, positive and negative carriers. Then by applying the bias, we can separate the charge carriers. So this one is the main reason for the photoreduction properties. But in the polymer composites, a polymer, it's what the polymer is doing. It's exciton dissociation by polymers. Means it's the recombination. It's avoiding the recombination, or it's reducing the time or increasing the time to recombination. So that is the main reason. Generated charge carrier, it's allowing time to separate for the both positive and negative electrodes. So this is the main reason to performance increasing. So in this case, we got the performance on-off ratio is around 10 power 5, directivity is 10 power 13, and the responsivity is 16 ohms per watt. So these are high performance still for the solution process, any kind of 2D material. These performance are very high. This work was published in Nature Communication. And again, this one is not a for one material, one property. So I checked with several materials, MOS, to make the film and the filter papers, and these materials showing different proper performance depend upon their band gap. I checked not only in the visible light, but also in the 1064 nanometer near NIR light, the various composites showing different on-off ratio. And importantly, it's depend upon the film quality, it's giving the very good performance. So among these materials, I got the poor performance for the zirconium telluride. It's visible here, the performance is, the film quality is low. And flexibility. Since I made this device on the filter paper, the flexibility is very high. So this one, you see this one here, it's a 5 millimeter diameter for the flexible devices. And so I checked on this one in the toothpick and the small earbuds. And also even we can make the flexible device on this one is the razor blade, one side, one edge blade. So in this case also we can make it. So the bending radius is, I can go up to 200 micrometer. So this one is ultra flexible devices. And also recently, it's called the Mexine. It's a new kind of 2D material. I used this material by using etching, remove the central metal atom, and we delaminate this one to form the single layer moly carbide Mexine. And with this one, you see, so when after this one, I got the very good instrument, high resolution HRTEM. So it shows the high crystalline nature, and we went for the HRTEM. It's here, clearly you can see the central metal, the nanoscale size of this Mexine. And this one is the 2 nanometer. You see the scale bar is the 2 nanometer. Even its solution process without any damage, I can make the very good material. And Mexine photodetector, among other 2D materials, this one is a kind of giving the absorption for all over the wavelength from 200 nanometer to up to 1500. And I don't have the facility to go for further beyond. So it's give the very good absorption. So we can make the broadband photodetector. So I make the device on again filter paper, and we make the device. And it's good, the decent performance around 3 order on-off ratio in the visible light, and also UV light and the NIR light. And also these 2D materials, it's a recent trend is making the non-layered material into layered 2D material. So I took the MOO3 as an example, molybdenum oxide, and I used the polymer, the pyrrole. The pyrrole is the starting material, the polymer. So by using hydrothermal method, I can make it polypyrrole coated MOO2. So from MOO3 to MOO2, by using the in situ polymerization process, I made this one. So here we can make the polymer composite for the energy storage applications. So this work is, I worked with the industry SABIC, and this one I have the patents. And currently, I'm working on the project called the neurofibers. So far, in the the spinal cord injury, so there is no solution up to now. So people are now using for the gold nanowires to bridge this spinal cord, broken spinal cord, but it's making several problems like incompatibility with the body fluid of the gold, and also its cost and everything is problem. So now I'm with a project called neurofibers. We are using the carbon graphene coated fibers to solve this issue. So here you can see this one is the fiber. We are coating the graphene and other 2D materials and checking the mechanical properties. So this one is my current work. And also I involved in the graphene flagship called very big €1 billion project for in the European country. There are several work packages. I'm mainly focusing on flexible electronics, energy storage, functional coating, and composite applications. Okay, in summary, so we can, by using the 2D material in the solution process, we can make the large scale preparation of stable and high concentration dispersion of 2D materials in various polar and non-polar solvents and polymers. And I developed a novel platform for fabricating thin film composites by simple techniques such as spin coating, vacuum filtration, and sprayed cutting methods, and utilized these for the flexible thin film optoelectronic applications. So these are the few publications, and also I have the one Korean and 3 granted and 3 filed US patents. And since it's a big family of 2D materials, so I would like to propose, so in the future I will work on, I suggest for all the people. So there are a lot of layered inorganic materials, like several things, MOS2, WS2, like these materials, and various organic compounds and polymers we can utilize and functionalize these materials with various functionalization strategies like chemical functionalization, covalent, non-covalent, ionic interactions, Lewis acid-base interaction, and also physical functionalization. It's a crystal on crystal matching interaction like epitaxial growth or epitaxial functionalization and 5-5 interaction. With these things, we can make the 2D inks various optimization process like controlling viscosity and hybridization, these kind of things. We can use for several applications like energy storage, some capacitor, battery, and electronics. In particular, the transistor or memories. And in addition to the trend is the flexible and stretchable devices. We can utilize these for these kind of application. And I would like to, as a summary, I would like to thank my PhD advisor in Yonsei University, Professor Cholmin Park, and Professor Andre Ferrari from University of Cambridge. And recently I got the Marie Curie Fellowship with Professor Sir Andre Geim at the University of Manchester. I'm going to work with him as he is a Nobel laureate. Not but least, father of Tamil nation, Periyar, for the social reforming to Tamil Nadu and making Tamil Nadu as a model state for India and comparable to the several European countries. Thank you. If you have any questions, please.
Thank you so much, sir, for giving a splendid lecture to us.
Yeah.
Yes. The elucidation of the 2D materials will help the research scholars to do their thesis or dissertations in an easy manner. I hope all the participants and the students and professors, they gain a lot of knowledge from this lecture, and the informations all you received in the perfect. Now, an active learning takes place only when there is a reciprocation. Now, I request all the participants to reciprocate with our chief guest through your valuable questions, suggestions, or compliments. So it's a time for question session. Thank you so much, sir, for giving your valuable lecture. The elucidation of our materials will help the research scholars to do the project and their in the easiest manner. I think all the points will give a lot of knowledge to all of us. The information is very useful for the future references. Those who are going to do research under the material changes. This information really helpful. Thank you so much, sir, once again.
Yeah.
Now, an active learning takes place only when there is a reciprocation. Now, I request all the participants to reciprocate with our chief guest through your valuable questions, suggestions, or the compliments. It is the time for your question session. I welcome the participants. If you have any questions, you can write to our chief guest.
Excuse me, sir. Excuse me, sir.
Yes, please.
Sir, I'm Dr. Divya Verpula from JNT University.
Yes.
Sir, in the slide, flexible band selective TMD photo detectors. Actually, It was a nice presentation, sir. We learned a lot from your lecture.
Okay, thank you.
Very much, sir. Thank you. And in this slide, you quoted gold nanoparticles over filter paper, no, sir? Flexible.
Yes. So this
Yeah.
one not a gold nanoparticle. This one is just gold layer.
Okay, but the coating was very uniform and for 100 nanometer diameter, no? Like around. So how the coating was done? Can you please suggest regarding this?
Yeah, the shadow mask I use. Okay. So on the top of this layer or any substrate or any material, you can put the shadow mask. So the shadow mask means so this gold covered area only open. The remaining area is closed by the metal. So when I deposit this layer, so I use the E-beam evaporator, okay, to deposit the gold. I will put the shadow mask on top of this film and put inside the E-beam evaporator and evaporate the gold. When the gold particle evaporates, it will touch the substrate. While using the shadow mask, the mask is covered like shadow. Okay, so when we want that area only is open, remaining area is closed. So this is the way to deposit by using this less area.
So this shadow mask will be commercially available, or we need to purchase it?
Yeah, you need to make some shadow masks are commercially available, but the area is little larger. For example, you can get it. I forget exact dimension, but you can get 100 micrometer gap. For example, channel length is 100 micrometer and channel width is 100 micrometer. Like the mask is available, and if you have the workshop, we can make it. Aluminium or vanadium materials are used to make these shadow masks.
Okay, sir. Thank you.
Without the shadow mask, you cannot make these kind of small channels.
Thank you very much, sir. Thank you. Thank you for your suggestion.
Thank you, sir. I request the participants to put your question on the chat box. Sir can answer on the chat box.
Hey, Dinesh, I have a very nice presentation.
Yeah, thank you.
Hey, Dinesh, can you hear me?
Yeah, yes.
Yes, it's a really good presentation and you worked very nicely. I just want to know about, have you ever faced the polymer aggregation when you do graphene and the polymer?
Yeah, the polymer aggregation means in the solution, we checked the 2D material, for example, not directly.
For example, yeah, I can
the
ask
conductivity,
you.
for example, the conductivity. So the polymer aggregation means it's after the time being. The polymer aggregated means we can see by the eye. Blind eye, we can see in the solution. But when we make the film, like for example, this kind of film, here the conductivity polymer start to aggregate. Conductivity will go very low. So that's the thing we will check for the aggregation, polymer aggregation.
Okay, my thing is like, have you tried to control to avoid aggregation, or is there any suggestion to control the
polymer aggregation in particular, these kind of 2D material solution, I will show you once.
I mean graphene and other polymers like polyamine or poly.
Yeah, I will come. 1 second. Yeah. So here you see the molecular weight is one important. Here, so when we use the high molecular weight polymer, the aggregation level is high. So try to use the low molecular weight polymer, but don't go below 5K. Then it's a oligomer. It won't give the much dispersion, the polymer property. Stick with 10 to 25 or 30K molecular weight, and also try to use the low polymer. And the sonication in between the time intervals, we need to give the sonication. So these are the easy steps to avoid the polymer aggregation.
You mean the 2D material and the polymer sonication?
Yeah.
I mean, 2D material.
For example, any 2D material, this one I use the TMD. Graphene also. The time being, is there any
Lots of disturbances are coming.
ಏನಲ್ಲ guys तेरी मेहरबानी
Are you able to hear now?
Yes, yes, some noise.
Yeah, so I will continue from the low, go with the low molecular weight polymer.
Yes, yes, yes.
As well as the in between the time intervals, please process the solution. For example, process means sonication. Apply some force in that one to separate the polymers, and also try to avoid use a large amount of polymers. Because when we add the polymers, all the polymers won't interact with the 2D material.
Yes, yes, yes.
Because the polymer chains level is very high. So start with very small amount of polymer. So that one is the easy way to reduce the polymer aggregation.
So another one more thing. So when you make a polymeric material and then you coat it with some filter paper, right? How do you do? Could you?
Yeah, I use the various filter papers. For example, nylon and PTFE filter paper.
Okay, what is the interactions during the coating? What are the methods you use?
Yeah,
What are the methods you use?
Actually, what I did. So only I checked. So here I'm not showing. So I checked the TGA. So how much amount of polymer interacted with the 2D material by applying the heating. So almost 70% polymers are not interactive with 2D material. Only 30% polymer in the total amount attached with the 2D material. So I want to remove the excess polymers because for the electronic applications. While using the filter paper, majority of polymers will go down. Okay, because the pore size is high. Polymer was soluble, but the 2D material is dispersed. So uninteracted polymers will go down in the filter paper. So it's no interaction between the filter paper and the polymers. It will go down.
Calculate how much amount is dispersed.
Yes,
on the
by
filter
using the
paper.
TGA, I calculated just only heated the polymer. For by seeing the peak, it's around 450 degrees Celsius. It's decomposed polystyrene. Okay, and terminated polymer. And after heating this one, so the 2D material and the 30% polymer remained. So the remaining is went.
Yeah. How do you coat with this polymer into filter paper?
So it's very simple. So just I took the filter paper and put on the vacuum sucker, and I put the paper and pour the solution, which contains
just normal filtration.
Yeah, normal as usual. The lab in the chemistry lab filtration process. People how to use the Wartman filter paper. Same.
Yes. So have you ever tried a polyethylene terephthalate or something?
PET coating. Yeah, I checked several. For example, one second. So this one is the PET substrate. It's able to coat. The only problem is the hydrophobic nature of the substrate. So when I need, so I process the substrate. So when I use the non-polar solvent or polar solvent, so depend upon the solvent, I process the substrate by using the O2 plasma.
Okay.
So
then you will coat it this polymer.
Yeah, then I coated, so I can get the good stable coating. Yeah.
Interesting work. Yeah, all the best.
Yeah.
Thank you.
Thank you. So if you have any other questions, so this one is my email ID. So you can contact me.
Thank you, sir, for the nice introduction.
I am unable to hear.
Yes, sir. Okay, is there any other questions from the participants? You can put it in the chat box, or you can ask questions.
Is there any question in the chat box? Please check. I'm checking.
Hello, sir.
Yeah, hello, hi.
This is Sugati from SRM Institute of Science and Technology.
Okay.
Actually, I have doubt about stability of your photo detector.
Stability.
Since you are using sulfide materials,
Yeah.
so I have a doubt about stability.
So,
Because it is easily oxidized with the environment. So,
yes, I will tell you. No need to worry, no need to doubt. Okay, its performance, it's well improved.
okay.
I will
Actually,
explain.
I'm also working in sulfide-based materials.
Yeah, I will explain you.
Okay. Okay. Thank you.
Yeah. Okay, chat, we can go later. So here you see stability. I have some extra color. 1 second. So to save time, I removed these slides. I have the stability curves. For example, this one. Okay, so this one bending radius, but you see the photo detector performance, okay, by
Okay,
time. You see here it's seconds, but you see of the day also I have up to 3000 hours also I have the performance. Here we use the polymers. The polymer doing the dual role. One is the dispersion, another one is it's providing the insulation on top of the layer. Okay.
Okay.
So the polymer is easy to pass through the light, so it won't affect the properties. But when we make the contact, only contact going through the 2D materials, the polymer act as an insulating layer. Here you can see the on-off ratio. Okay, different time intervals. It's stable. It's highly stable devices.
Okay, sir. Okay, if we are going beyond that seconds means like
So unfortunately, I don't have that slide, but you can check my recent advanced material paper. I have up to 3000 hours stability of these devices. The photo detector.
It's when you are adding polymer with the 2D materials, right? So in the case of only sulfide materials means
So what kind of material, for example?
any material like sulfide materials, any material, 2D material or ternary material, like it can be anything. But
For example, I also faced this problem. So that one, when it will we make the device will interact with the atmospheric oxygen. Okay.
Yes, sir.
So maybe I guess you don't get these kind of stable on current. So when you apply the more time, the on current keep on increasing. I guess, right?
Yes, sir.
Yeah. So that one is due to the atmospheric oxygen. It will interact. So it's for increasing the current level. The only solution for that one is you need to insulate your device.
Okay, with polymer or any other?
With any insulating material. So do you have the ALD facility?
No, sir.
Okay, then easy is the polymer coating. After making the whole device, you can coat very thin layer of PMMA.
PMMA.
Yeah, very thin layer. And also while you're making the contact, you should scratch the polymer on top of your electrode. Okay.
Okay, sir.
You can scratch by forcing the tip for a little more. You can scratch the polymer, you can contact. You need to make sure your tip is contact to the electrode. That's it.
Okay, sir.
Yeah. So what's your channel dimension, channel area?
Actually, I'm working in solar cell applications. But I'm thinking to work in photo detectors also. So yeah, I had doubt.
Okay, so then no problem. Please try to make insulated devices when you are using in particularly zinc oxide and sulfate materials like MOS. And if your MOS, for example, is stable, you can heat.
Okay, sir.
So put in the oven for 200 degrees Celsius. If your material is stable, put 200 degrees Celsius for 2-3 hours.
Okay, sir.
Okay. And also try to measure in vacuum. So these are the solutions.
Okay, sir. Actually, already I have composited with carbon-based materials. So What about that one? Like, what about that carbon-based materials? Like, it will be helpful with this stability problem or
The carbon-based materials means, for example, you need to tell the
graphene?
example. Graphene.
Graphene.
Yeah,
Yeah.
graphene is fine.
Okay, sir.
But
So,
graphene oxide, reduced graphene oxide, again, you will see the same problem like zinc oxide.
yeah, that's only, sir.
Yeah, yeah. So the same like reduced graphene oxide means you will face the same zinc oxide problem. Only solution is insulation problem.
Insulation.
Yeah, you need to insulate your device.
Okay,
Or
sir.
you need to measure under vacuum.
Okay.
If you measure under vacuum, you can see the stable
Okay.
devices.
Okay, sir.
Yeah.
Okay, sir. Thank you, sir.
Yes, introduction, ma'am. There is a small information to the participants. We have sent the feedback link in the chat box. Please, I request all the participants fill the feedback form. Is there any other questions from the participants? You can ask. The participants, if you have any doubt, if you have any questions, you can ask now. Okay, thank you. Thank you, sir, especially on the behalf of PG and Research Department of Physics. We thank you very much for sparing your valuable time with us.
Yeah.
And also thank for your nice presentation. Thank you so much, sir.
Okay. Thank you so much for this opportunity. I particularly thank once again thanking the management and also the physics department faculties, and in particular Dr. Ravi Kumar. Thank you so much.
Thank you, sir.
Bye. Have a nice day. Bye.
Thank you, sir. I will request all the participants. We will start the oral presentation now. So all the participants stay here and be prepared. The oral presenters, be prepared for the presentation. It will continue a couple of minutes. Yeah, we have successfully completed a session and we have a oral presentation. I request all the oral participants be ready for the presentation. As per the schedule, they will call you. They will unmute your name. You can come and you can share your screen. You can explain your concept. Then after that, the expert will ask you questions. You can answer them. Okay, be ready for that. All the oral presenters. They will call you by the schedule. We will display your poses. Just you can explain your concepts. Okay. Okay, the next session will start. You can speak well if your tongue can deliver this message from your heart. Now I would like to call upon Dr. C. Lavanya ma'am. In this oral presentation, we have two distinguished guests. They are going to act as a judge. All the presenters try to prove your talent, and the remaining and the participants be ready for to taking the notes. And if you have anything at last, you can raise the questions. This presentation will help us to prove our talent. It's a chance to expose our skills in the field of material science. Even all the slides, all the participants is going to talk about advanced material science. So be ready for that. Talent is an adornment. An adornment is Nietzsche. He proposed this quote because of talent will prove an individuality and the uniqueness. Here, all the participants going to show themselves the uniqueness. I request all the participants stay for a couple of minutes. We will start the session soon. When we come to oral presentation, presentation is a kind of art. Even those who have become a leader of this world, India, some other countries, they can, through their talent, through their speech, through their art of skill. So here, this is a chance for each and everyone to prove yourself. Yes, we happily announce those who are going to present the oral presentation. I'm going to list out the name of the presenters. There are 17 presenters are there from various institutions, various colleges, research scholars, students, and professors. Just I list out the names. First, as per the slab order, first P.V. Dhanraj from Malabar Christian College, Calicut. Second, Dr. Satyajit Chauhan, Assistant Professor, Others College, Kingauli. Yes, Hasina, Assistant Professor, Muthaimal Memorial College of Arts and Science, Namakkal. Remy Dari, PhD Research Scholar, Faculty of Science, CAPSA, from CAPSA. Dr. Pierre Lal, slot number 6, Assistant Professor, Banastali, Vijaypit, Rajasthan. R.B. Narmada, slot number 7, student from Kalasalingam Academy of Research and Education Institutions. Then slot number 8, D.P. Nagamuruga, student from Sriram Engineering College, Avadi. Then slot number 9, Magadha Oza, research scholar, Shastra University, Rajkot. Then Imin Teli, slot number 12, PhD scholar, Faculty of Sciences of Affects, KAPSA. Then slot number 14, Dr. Divya Velpula, women scientist, JNU Hyderabad, from Hyderabad University. Preetima K, slot number 7, a student of RMD Engineering College, Chennai. Then Srisha, slot number 18, PhD researcher, Jawaharlal Nehru Technology University, Hyderabad. Then Rafiq Mullah, slot number 19, postdoctoral research scholar, Swansea University, Swansea, from UK. Then R. Radhika, slot number 21, PhD scholar, Gobi Arts and Science College, Gobi Chettipalayam. Then H.R. Pradeep, slot number 23, research scholar, Kongunara Arts and Science College, Coimbatore. M. Ramudai, slot number 24, research scholar, Kalasalingam Academy of Research and Education. Then last, Dr. D. Saravana Kumar, slot number 25, assistant professor, Tyagaraja College of Arts and Science, from Madurai. All the participants, be ready for your presentation. We'll start a couple of minutes. Dear participants, I just once again remind you, in the chat box, you have a feedback link. Please fill out the feedback form and send it immediately. This feedback form is considered attendance for the first session. So don't forget it. Please be fill in the form. And we have one more participant, Vasumati, research scholar from Thoothukudi. She is also going to join. I would like to congratulate all the participants for the new session. There are some instructions for the oral presenters. First, you have 5 minutes time. You have to present for 5 minutes. Then the next 2 minutes for your question sessions. If any participant wanted to ask questions, you put it in the box, or you can ask directly to the presenters. Last 2 minutes. For first 5 minutes, they are going to present their presentation. Then next 2 minutes for the question session. Between the 5 minutes, don't interrupt the presenters. After finishing the concept, you can ask any questions you can ask them. Let me start the session. Be ready for all the presenters. You can speak well if you can speak well if your tongue can deliver the message of your heart. Now, I would like to call upon Dr. C. Lavanya, Assistant Professor, Department of Physics, to introduce the chief guest.
Good afternoon, everyone gathered here. First of all, I welcome. It is my privilege to welcome our chairperson, Dr. Balaji Murugan sir. Welcome you, sir. So, sir has completed his PhD degree in Sri Ramakrishna Mission Vidyalaya College of Arts and Science, Bharatiya University, Coimbatore, during the academic year 2014 to 2017. He is currently working as a assistant professor in Bannariamman Institute of Technology, Erode. He has 3.5 years teaching experience and research experience also. Sir has published 22 papers in international conferences, and also he has participated various conferences in various institutions. Thank you, sir. I welcome you, sir.
Thank you, ma'am. Thank you for your introduction.
Thank you, sir.
Thank you so much, ma'am, for giving a
For this occasion, once again, I welcome another chairperson, Dr. K. Saktipandi sir. So, chief introduction. So, it is my privilege to introduce our chief guest, Dr. K. Saktipandi sir. He has completed his PhD degree in Anna University, Chennai on 2013. Sir is currently working in SAID Institute of Technology, Kariyapati. He has more than 16 years of teaching and research experience in various institutions. He got Young Scientist Award, Sir C.V. Raman Award, Best Teacher Award, and so on. He has also completed postdoctoral fellowship. He got nearly 11 awards, and also he got 10 fellowships like Young Scientist, Senior Research Fellowship, Summer Research Fellowship. He produced 1 patent, and also he received research fund nearly 1 crore. He published 63 papers in international journal and 2 papers in national journal. He has also attended more than 120 national and international conferences both in India and abroad. Under his guidance, 2 scholars have completed their doctoral degree and 4 scholars are pursuing their PhD degree. So also, Sir has contributed, act as a co-author in 3 research books, and also he is a member in the Board of Studies and Doctoral Committee in Anna University, Bharatiyar University, and Mananmaniya Sundarnar University. He acted as a editorial board member and also acted as a referee in International Journal and National Journal. He has visited more than 15 laboratories. So he has also membership in various professional bodies. Thank you, sir.
Thank you so much, ma'am, for giving the chief guest introduction. Best way to conquer stage fright is to know what you are talking about. Now I wish to welcome our honorable chief guest, Dr. M. Balaji, Assistant Professor, Bannari Amman Institute of Technology, and Dr. K. Sakti Pandi, Assistant Professor, Sethi Institute of Technology, has acted as a chairperson for this oral presentation. On this great occasions, I welcome all the participants who are gaining the knowledge of advanced material sciences. Let's start the session.
Good afternoon, everyone. Now we started the oral presentation. The slot number 1, P.V. Dhanraj from Malabar Christian College, Calicut.
Thank you, sir.
Okay, Dhanraj. Now you present your screen.
I have to present it or
yeah, you have present your screen.
okay, sir. You can see the presentation.
Yes, sir. Yes, sir.
Okay, good afternoon to all. I am Dr. Dhanraj PV from Malabar Christian College, Kozhikode, Kerala. First of all, here I am going to present my works on the investigations on growth and properties of NLO 2-aminopyridine organic crystals. First of all, the motivation for this work are the identification, design, and synthesis of new molecules, the tailoring of molecular structure for enhancement of NLO properties, and to promote crystallization of potentially useful molecules and the characteristic studies. Here, in search for new NLO crystals is an important area. In this context, organic materials have particular interest because of its high nonlinearities, large optical susceptibilities, and inherent ultra-fast response times. Literature shows that the organic donor pi acceptor type compounds with the pyridinium acceptor has high nonlinearity. So here I tried trichloroacetic acid with 2-aminopyridine from the crystal engineering viewpoint. So this is the synthesis, that is the compound synthesis by dissolving 2-aminopyridine and trichloroacetic acid in the aqueous solution from room temperature. And this is the solubility and metastable zone width studies. Here the metastable zone width is this curve. This is studied by the polythermal method for different temperatures. And these are the Ascron 2-aminopyridine trichloroacetate single crystals by slow evaporation method. And from I undergone the single crystal accelerated studies, and this is the crystal structure diagram. And here the pyridine nitrogen is more basic than the amino group at its ortho position. Because of this difference in basicity, the pyridine ring nitrogen can be immediately protonated in preference to the amino group when trichloroacetic acid is added. So here the protonation facilitates hydrogen bonding interaction between the trichloroacetic acid and the protonated 2-aminopyridine as shown in the structure diagram. And these are the structural data parameters. So this crystal belongs to the monoclinic system with the space group P21 bar C. And these are the crystal structure data parameters. And this is the molecular packing diagram of 2-aminopyridine trichloroacetate. Though the pyridine ring nitrogen proton is bonded to trichloroacetic acid or trichloroacetate, the positive charge on the nitrogen is more imparted to bring closer and another trichloroacetate hydrogen bonded to a separate protonated pyridine as illustrated in the packing diagram. And these are the bond lengths in 2-aminopyridine trichloroacetate molecule. And these are the bond angles. These are the hydrogen bonds in this molecule. And this is the morphology diagram. So this crystal has two prominent faces, 100 and 100. And this is the powder X-ray diffraction spectrum. It shows that the crystal has good crystallinity. And this is the high resolution X-ray diffraction spectrum from the NPL Delhi. Here, this crystal has excellent crystalline perfection because of its single diffraction curve with the low FWHM value and the absence of structural grain boundaries. And this is the FTIR spectrum and the tentative assignments. And in the thermal studies or TGDTA studies, the sharp endothermic peak at 124 degrees Celsius is assigned to melting reaction of this crystal. And the sharpness shows that the crystal has good crystallinity. Here also the weight loss is observed simultaneously with the endothermic reaction. So there is not only a melting reaction, but also the evaporation. So this leads to the sublimation of the compound at this temperature. And these are the dielectric constant and dielectric loss measurements of the crystal. So both the dielectric constant and dielectric loss have maximum value in the lower frequency region and then decreases with the applied frequency due to the presence of all the polarizations. The low value of dielectric loss at a high frequency implies that the crystal possesses good optical quality with lesser defects. And it is the mechanical hardness studies. Here at low loads, the intender penetrates only the top surface layers, generating dislocations, which results in the increase of hardness in this region. And the load independence of hardness at a higher loads can be attributed to the mutual interaction of or rearrangement of dislocations. And this is the UV visible air study. And the crystal has the cutoff wavelength at 354 nanometer. And it has a transparent in the entire range without any absorption peak. And I conducted the Z-scan technique used to determine the third order optical nonlinearities of this crystal. And this is the experimental setup. And these are the Z-scan spectrum for the closed aperture and the open aperture. And here it is the resultant spectrum of division of closed aperture spectrum by open aperture spectrum. And from these studies, the values of nonlinear refractive index and the nonlinear absorption coefficients are given. So it is contribute to the third order nonlinearity of the 2-aminopyridine trichloroacetate crystal. So finally the conclusion. So we ground the 2-aminopyridine trichloroacetate NLO crystals by slow evaporation technique for the first time. This is the monoclinic system is a system and with its space group P21 bar C. In the complex formation, protonation of pyridine ring nitrogen facilitates hydrogen bonding interaction between acid reactant and 2-aminopyridine. The HRXRD analysis substantiates the good quality of the crystals. Thermal, dielectric, mechanical, and optical behavior of crystals were analyzed. The Z-scan measurements indicate that the 2-aminopyridine trichloroacetate exhibits third order nonlinear optical properties. Thank you.
Thank you, P.V. Dhanraj, sir.
Thank you, sir.
Participants, if any questions?
Balaji, sir.
Sir, no problem, sir. We will move next.
Okay,
If there is any queries from audience, we can wait. Otherwise, we will move next. Okay, sir. Next one.
Thank you, sir.
Okay.
Thank you for this opportunity.
Thank you, Dhanraj sir.
Thank you, sir.
Next, slot number 2. Now I call upon Dr. Satyajit Chavan.
Raja.
Sir.
Raja, I just give you one information to the presenter.
Okay, sir. Okay, sir.
Dear presenters, if you have a possible, we will give you a co-host to you, and you yourself, you share your screen and you will present, right? And another important thing is you skip the introduction and directly go to the work, because short of time we will complete up to 1:15. Nearly 15 presentation is there, so directly you go to the work. And Raja sir, you just called your name, and after that we will give you a co-host to the presenter. You just present the screen. If you have any difficulty to present the screen, you just inform the chat box, we will share the screen, right? Okay, thank you. Raja sir, you continue.
Okay, thank you, Ravi Kumar sir. Now I call upon Dr. Satyajit Chavan, Adas College, Hingoli.
Hello.
Sir.
Yeah, I'm. Yeah, am I audible?
Yes, sir. Yes, sir. Audible.
Hello. Yes, sir. I have some technical problem that I cannot share my laptop PPT. So, if it's possible from your side, I will.
Yes, sir. Yes, sir. Sure, sir. I will share your screen.
Yeah, and with the cycle, I will say next. Then, in that case, forward it, please, kindly.
Okay, sir. Okay, sir.
Yeah.
Yeah. Satyajit sir.
Yes, sir.
Please wait a few seconds. Small technical issue is arised.
Yeah, if there is problem, can I send PDF if there is problem regarding
Sir,
that.
if you have any possibility, you just share your screen. We will give you a co-host to you.
It is technically right now I found a problem with
Okay, sir.
laptop.
No problem. No problem. We will send. Okay. Okay, sir. Okay.
Yeah. Can I start, sir?
Sure.
Yeah, thank you for technical assistance and everything for the organizers giving me opportunity for this presentation. Basically, my name is Dr. Satyajit Chauhan, and I work for the material science and basically for the liquid materials. And today I'm representing here as a comparative dielectric study of methanol water and the PEG, that means polyethylene glycol 400 water mixture using time domain reflectometry technique is to be there. Basically, why what it contains. Next, please. In this basically introduction part, experimental technique, result discussion, conclusion, and references as a part of it. Next, please. Basically talking about the dielectric constant, everyone knows that what exactly meaning to be as an dielectric constant, but in brief here it is to be shown. But before that, I will start with my 2 points. That is to be, I have taken mixtures, that is to be alcohol, primary alcohol, and the long chain polymer is to be there. So what exactly my idea about studying these two mixtures with the soluble, which are soluble in the water, that is to be with the short chain alcohol, I am trying to compare with the long chain of the polymer. What exactly the dielectric parameters relation or how they are differ from each other, and that is what the comparative study is to be there. Both the liquids, that is either our alcohol as well as polyethylene glycol 400 is soluble in water, but with the short chain and the large chain, that is to be interesting to study what exactly happens with the dielectric constant. In generally, we are aware in short, that is how the dielectric constant is meaning to be there with the capacitive part. Here it is to be shown in this slide, that is simply with the capacitance per unit area, that is to be here shown what exactly to be as an epsilon 0, C by C0. It is a general known thing, that's why we will not spend so much time on this. That is what the static dielectric constant we can say, and having the relationship given here. So moving forward, next please. Here is the basically the using the technique, the d by static dielectric constant calculated epsilon 0 minus 1 upon epsilon 0 plus 2 is equal to the relationship is given. Next please. Here it is to be again with the Onsager dielectric theory and the Kirkwood correlation factor, G effective factors are going to be calculated. We are not spending for this theoretical part because as it is to be related with the basic things. What exactly we, next please. Again here the Kirkwood factor, where the G effective factor which will give us the relationship as far as the mixtures are going to be there. That is where the G value is greater than 1 or the lesser than 1, which gives us the electrical dipole interaction in between this. And wherever we are calculating these values or in comparison, that we will see in detail. Next please. The loser model here we are not studying, but the G1 and G2 values that are quite interesting to learn what exactly the correlation as far as the solute solvent relationships are to be there. Next please. Again next please. Next please. Yeah, here is the experimental technique. In short, in brief, I will explain here. That is the TDR, time domain reflectometry technique is to be there. One pulse, if you have seen here, RXT is reflected pulse and R1T is the incident. That pulses are going to be 1, not 20 pulses are continuously going on. And in this, what exactly the sampling head is to be there, having the liquids we can put into it, and sample head is having that liquid mixtures, and we will get the reflected pulse, and the sending pulse are to be shown here with the R1T, and the reflected will get the data regarding this. Next, please. This one is the digital oscilloscope 54750A 0 to 20 gigahertz instrument, which is going to be used. Next, please. This is what the setup. Next, please. And this is what the sample cell where we can put our basically liquid, and we get the reflected pulses with the sample and without the sample. Here that head, that is height, is also to be mentioned here. That is nearly very small thin edge is to be there, and using this we can get the data. Next, please. Yeah, that is what the reflected pulses without sample and with the sample. For the methanol, I am just showing here the blue line indicating that without the sample reflected pulses are to be there, and for the methanol how the change is to be there, deep is showing to be there, and that is what the reflected pulses without sample, and with the sample we have the relationships are to be there. Next, please. And here is to be again the pulses modulation, some applications, basically softwares are going to be used to find out the with and without the sample what the reflected rays are to be there. For the number of points continuously pulse is going to be there given, and the reflected pulses we can get for the as well as the without the sample what we get, and the with the sample for the methanol we are getting. Next, please. Now here basic comparison for the what the our parameter, basically the liquids we have chosen. Water, where it is to be having the molecular weight, it is 18 nearly 0.01, and the methanol is to be 32.04, and polyethylene glycol 400, it is to be as we know the bigger one. Now here what the important thing is to be comparison for the basic parameters. Basically water, where the both the methanol and the polyethylene glycol 400 mixable, and having one is to be the smaller chain, that is to be having the molecular weight lesser, and the larger, that is the polyethylene glycol 400 is having to be. That is the important thing to compare what exactly the bigger molecular weight and the smaller molecular weight variation in the dielectric parameters we can see. Density part is to be there, it is very small variations as far as the density compare with this particular three liquids are to be there. Next, please. Now this is what exactly we are discussing for the what we are getting for the dielectric constant for the methanol water mixture and the polyethylene glycol water mixture is to be there. Here interesting part is to be we have calculated here to be as an static dielectric constant for the both the mixtures. That means one mixture is methanol with water. If you look at this case where the blue line is showing that mixture for the methanol and water mixture, it is from the 10% to going on, that water is going to be added 10%, and lastly at the end it is having the 100% water is to be there. That variation is showing us that methanol is having the increase as far as the slowly increase in that particular dielectric constant range is to be there. As far as the polyethylene glycol and water mixture is having the similar one. But if you look at the comparison as far as the dielectric constants are to be concerned, it is having the pattern same, but as compared with the methanol, pure methanol and the polyethylene glycol 400, they are having differences in their dielectric constant due to the whatever be the bulky molecular weights and the bulky molecules are to be there. It is having the differences in between the dielectric constant, that is volume volume variation is to be along the x-axis, and along the y-axis this static dielectric constant is to be shown. Next, please. Next, please. Yeah, here is the what exactly the relaxation time. It is to be as an backward, that relaxation time. Previous one, sir. Here is the dielectric relaxation variation in between the methanol water mixture and polyethylene glycol water mixture is to be there. If you look at as the it clearly showing that either the water percentage is going on increasing, it is how the molecules is become lighter and the relaxation time is goes on decreasing. But if you look at the whatever be the relaxation time as far as the methanol and the polyethylene glycol is going to be concerned, the polyethylene glycol, as it is very much bulky, it takes larger time to reorient its position, and that's why the relaxation time for the polyethylene glycol is having to be larger as compared to methanol water mixture is to be there. Though there is a pattern decrease as far as increasing the water, but there is a large difference as far as the polyethylene glycol 400 is going to be concerned and the methanol is going to be concerned. Next, please. Here is the G effective values as the water is percentage is going on increasing. At the last, both are having the similar values, but the deviation as far as the methanol and the polyethylene glycol 400 is going to be concerned, there is a large difference as far as both are having the greater than 1 value, but it is to be showing us clearly that polyethylene glycol 400 is having the larger orientation as compared to the our methanol water mixture is to be there. Next, please. Now G1, G2 values are somehow greater than 1 orientation with the parallel and the orientation with the greater value than the 1 and the lesser than 1. That indication is for the parallel orientation and anti-parallel orientation is to be there. And this is what again it is showing that polyethylene glycol 400 water mixture is having the greater one than the methanol water is going to be concerned. Next, please. Here is again, but somehow differences are larger, but the values as far as the G2 is going to be concerned, methanol is showing the greater one as compared to polyethylene glycol. Next, please. Here is to be the most important factor, that is the comparative dielectric parameters as far as our methanol polyethylene glycol is going to be concerned. Water is where both the liquids are going to be mixtured that can be soluble in the water are to be there. But dipole moments are going dielectric parameters constants are, if we look at for both the cases as far as methanol and the polyethylene glycol is to be there. As the molecular weights and the bulkiness, the methanol is having the 33.7 and as polyethylene glycol is having 14.1. But as far as the second line, that is relaxation time is going to be concerned, if you look at the water is showing the very small, as we know that is to be very light molecule is to be there, water molecule, as compared to methanol and polyethylene glycol. But when we are discussing for the methanol mixture, methanol water mixture and polyethylene glycol, if you look at for the pure methanol, it is 64.95 and nearly 65, and the polyethylene glycol is having too much high, that is nearly 96.9, that means 97 is to be there. That means the relaxation time is so much greater as comparison in between the methanol and polyethylene glycol is going to be concerned. And when we are mixing water, or that is both the solutes are soluble in this water, they are showing us in the same way, pattern is going to be in that same way, from larger to the lesser one, relaxation time is going to be there. As far as density part is going to be concerned, it is having very less variations are to be there. So it is somehow clearly indicating that as the polyethylene glycol is to be much more bulky, it is having the larger relaxation time as compared to water mixture is also having the larger relaxation time as compared to the methanol water mixture is going to be concerned. Next, please. These are some references where we are working for the different comparatives parameters related with the molecules, alcohols as well as polymers are to be there. Next, please. And thank you very much for everyone for the giving coordination from the organizing committee as well as all the chairpersons are to be there.
Thank you, Dr. Satyajit. It was nice presentation. Can you specify any recent applications related to your work?
Recently, we are working for the polymer things, sir, because the polymers
actually in our daily life we are using some applications. which relates?
Basically, basically wherever we are using the plastic as a in our day-to-day life, these part are very much important to know, as far as not only the polymers used is part is to be there, but in electricity also, whatever the material is going to be used nowadays as an insulating material, where these parameters are also going to be useful for calculating these things are to be.
Okay, Dr. Satyajit, thank you.
Thank you, sir.
Is there any query, audience?
Yes, sir.
Sir, can you hear my voice?
Yeah,
Yes.
Yeah.
Satyabandi sir, welcome
Yes,
sir.
Actually, what is the method to used to conventionally used to relaxation time?
Used to.
How the
Sorry?
people that conventionally used to relaxation time, how they measured?
Yeah, basically what the technical I have shown here with the TDR, time domain refractometry technique, that one is the older one. Nowadays the highly
Different technique. What is the conventional methods are used nowadays, sir? In practice, what are
but
the
basically can you repeat, sir? I can means
relaxation time can be obtained by various ways, sir. You are approaching in different way. What are the different ways to approach a relaxation time? What is the conventional one?
I haven't tried, but basically I have gone through this either the frequency X band or somewhere smaller frequency range LCR meter is also to be there. But I haven't tried for the different methodologies for the calculating the orientation time. But that
So
basically gives you what the for small voltage, it gives you how it will takes to be as an polarized for that ions are going to be polarized for that plates, and then after removing the voltage they will go to the their original position.
What is the standard error when compared to your method to that?
Yeah, nearly it is having the 1 to 2% error is to be there, very less error. That is why it is to be accepted for working for relaxation, calculating the relaxation time, and the dielectric constant parameters are to be there. Nowadays, very high frequency range time domain. Sorry.
In your reference liquid, it is not a linear liquid. It is showing some parabola type, I think so. Your reference liquid. It is not a linear one. Usually the people will need the reference as a linear one. Then only we can compare what is happening at the linear with the another one. So
yeah, definitely. Actually, I'm here concluded very short part in not given in detail. Actually, I want to give you with the loser model also in detail. That will be give us how the theoretical model giving us basically the as far as the experimental values, as far as the theoretical values, that somehow gives the relationship what exactly the correlation, correctness, errorless is to be there.
Okay, sir. Fine. Thank you.
Thank you, sir. Thank you very much for cooperation.
Thanks.
And participants, my small request to you all, please give a small intro about the research topic and directly and that's enough. No need to explain a single thing. You understand? Okay, next one.
Now, come to the slot number 4. Yes, Hazina from Muthayamal College of Arts and Science, Namakkal. One more instruction to the oral presenters. Kindly complete your present within 5 minutes.
Good afternoon, everyone present here. Sir, can you share my PDF, sir?
Yes, ma'am. Yes, ma'am.
Thank you, sir.
Hasina ma'am.
Yes, sir.
Ma'am, due to the technical problem, you can share your screen, ma'am.
Sir, 1 second, sir.
Okay, okay.
Sir, now it's okay, sir.
Yeah, ma'am, it's okay. You can start now.
Okay. Good afternoon, everyone present here. And today's my topic is hydrothermal assisted green synthesis of iron oxide nanoparticle using Lucas aspera and Jatropha podage leaf. Actually, in Tamil, it is called as Tumbai and Amanakku. I did this in green synthesis method. Next. And nowadays, these organic dyes effluents from the textile industries are one of the major part of the organic substance which lead to severe damage for water resources and great loss of acoustic living things. These are the organic dye present in the textile industries. Next. And these are the effects which we are calling as BOD and COD, that is biological oxygen demand and chemical oxygen demand. Next. And this is the treatment. These are all the treatment methods. In that, I have took that photoelectric method, that is chemical approach. Next. And this is my application oriented, that is dye degradation using metal oxide photocatalyst. Actually, what is the mechanism means when the photon having energy which is greater than the band gap energy, when it is incident on the photocatalyst, that is what we are using as iron oxide. That electron can transfer from valence band to conduction band and produce the same amount of holes in the valence band. Now the electrons and holes can react with the water molecules and dissolve in oxygen in water, which generates the superoxide anion radials and OH radials. These superoxide anion and OH radials can easily decompose the methylene dye, which is used here in the aqueous solution. Next. This is the structure that is Fe2O3. That is the N-type semiconductor, and it has the rhombohedral shape. Next. And now we are coming to the preparation method, that is the hydrothermal preparation. I took both the leaf and washed in the double distilled water, dried for 24 hours in normal room temperature, crushed, and it is filtered. So next. These filtered leaves is added with the 1 mole of ferric chloride in 20 mole, and it is slowly stirred. And it is slowly stirred for 2 hours, and it is again transferred to autoclave for 12 hours at 120 degrees Celsius. And again, this mixture is again transferred to centrifuge, and it is dried at 110 degrees Celsius for 12 hours. And the gained particle is the Fe2O3 nanoparticles, that is iron oxide nanoparticles. Next. And this iron oxide nanoparticle I took for the X-ray diffraction third. That is obtained nanoparticle is nothing but a form of crystal. When it is undergoes the X-ray diffraction, it gives the peaks, and which is of standard data of Joint Committee on Powder Diffraction Standard. From this, we suggested and concluded that it is a rhombohedral shape. And the size of the particle is calculated using D-base formula. It is about 59 nanometer and 44 nanometer. And again, phytochemical exists on the leaf significantly controls the nanoparticle. Next is FTIR, and FTIR is used to measure the light absorption of mid infrared region. From this, we can find the functional groups and water molecules. What functional groups means? And next I did for next I went for SEM. The SEM is nothing but to morphological analysis. HRTEM, that is high resolution TEM, results in the size of the particle is about 3 nanometer with polydispersed in nature. And then EDX, that is energy dispersive X-ray spectroscopy, and this is confirmed the presence of elements such as iron and oxide in the sample. And then SAED, that is selected area electron diffraction pattern, shows the polycrystalline nature of the sample present. Next, UV-DRX, that is nothing but diffused reflectance spectroscopy. From this, we have observed that the coefficient of incident photon energy reveals the band gap, and the band gap is about 2.41 and 2.50 electron volt respectively. Next, photocatalytic analysis. 100 mg of photocatalytic in 100 ml of methylene blue is took, and it clearly shows it undergoes the decomposition, but it clearly shows the photocatalytic activity of the first sample is significantly higher than the second one, and it is about 99% and 97% in 18 minutes of light irradiation. Next, conclusion. Iron oxide nanoparticles with different nanoscale characteristics has been successfully synthesized by hydrothermal assist method, and prepared nanoparticles were characterized using different analytical techniques to know characteristic features such as phase purity, structural property, band gap, morphology, and particle size. The obtained result from the various characterization evidently gives these two plant extract not only the reduce the iron chloride into iron oxide under the hydrothermal circumstance, but also it plays a vital role in phase purity, optical absorption, and particle size of the nanoparticle. Further, the photocatalytic degradation of methylene blue or rhodanium blue be prepared was significantly influenced the type of plant extract used in the preparation. Next, I have compared these two plants, and it shows that the first one, Lucas aspera, shows 2.1 electrovolt as a band gap, and this is the 5.0 electrovolt. And from this photocatalytic degradation efficiency, the first plant, that is Lucas aspera, took 99%, and the second one, Jyotrafa bodaria, gives the 97%. From this, I conclude that after comparison, the best one is this, the first one, that is the Lucas aspera. Thank you, sir.
Nice presentation, nice. Any questions from audience? There is no, we will move. Audience, once again, my request, please talk about your research work and directly go to R&D section. I mean resultant and come to your conclusions. It's enough to finish. Try to finish in 5 minutes, please.
Okay, next. Slot number 5, Rimini Dihari from Tunisia. Rimini Dihari is here. Once
Good
again, I
morning.
call upon
Yes,
Rimini
good
Dihari.
morning.
Welcome, Rimini.
Thank you.
Now you start your present.
Okay. Is it clear now? Mm. Is it clear now? Can I start?
Start, ma'am.
Thank you. Good morning, everyone. I am Rimen Dahri, Tunisian chemical engineer and PhD student from the Faculty of Sciences of GAFSA. I'm here to present my work, batch adsorption study experimentals, Langmuir and Frantish isotherm studies for the adsorption of methyl green onto activated carbon. I would like to thank the organizer and all the sponsors to provide me with an opportunity to present my work. Next slide. So starting with a short introduction, the development of the industry environmental contamination has become increasingly alarming. Thus, the problem is further aggravated when it comes to toxic pollutants, such as organic dyes, in particular the synthetic dye, the methyl orange. So a number of treatment technologies have been adopted. Removal of dyes from wastewater. Among these processes, adsorption is one of the most favorable and economical methods, and activated carbon is mostly used for treating wastewater due to its important porous structure, its high surface area, and high adsorption capacity. Motivated by search of a new precursor, prickly pear seed cake has been considered in this study. This raw material was chosen as precursor in the preparation of activated carbon because of its availability and its physicochemical characteristics. The main purpose of the present study was to evaluate the feasibility of developing activated carbon with large porosity from prickly pear seed oil extraction. Phosphoric acid activation was applied to produce an activated carbon. The preparation of activated carbon, first prickly pear seed cake was carbonized, then activated using phosphoric acid. The residual phosphoric acid was eliminated from activated carbon by washing with hot distillator water under neutral pH. Batch adsorption experiments were carried out to evaluate the effect of process parameters, pH of solution, adsorbent dose, contact time, and initial concentration in the solution. For the characterization of activated carbon, observation under a scanning electron microscope shows that the obtained carbon has a highly porous structure, and the infrared spectra of the adsorbent prove the presence of alcoholic, carboxylic, and aromatic functional. The results of kinetics adsorption study shows that the regression coefficients for the pseudo second order model were very close to unity, indicating that the adsorption of methyl orange follows the pseudo second order model kinetics, which is generally used to describe chemisorption process. For the effect of pH, the results indicated that activated carbon is an efficient adsorbent for methyl orange in acidic conditions. For the effect of adsorbent dose, there was an increase in adsorption capacity whenever there was an increase in adsorbent dose. The equilibrium adsorption data for the methyl orange activated carbon system were analyzed. The fitness of Langmuir model of the adsorption process points that the methyl orange was adsorbed on specific monolayer onto the obtained activated carbon. For the thermodynamic study, the values of Gibbs-free energy are negatives, indicating the spontaneous adsorption of methyl orange. Furthermore, Gibbs-free energy decreased by increasing temperature from 15 to 40, indicating that the spontaneous nature of the adsorption increased with the increase of the temperature. The positive values of enthalpy and entropy involves an endothermic adsorption process and an increase in entropy. Finally, as a conclusion, the study revealed that activated carbon synthesized from prickly pear seed cake is suitable for methyl orange removal from industrial wastewater. The obtained results shows clearly that the use of this raw material has important advantages, not only in terms of agricultural wastewater valorization, but also in regard to decrease of methyl orange concentration in wastewater. I would like to thank my supervisor, Mr. Yunus Moussawi, for his constant support and guidance during the running of this project. Many thanks to all participants that took part in the study and enabled this research to be possible. Thank you for your time and for your attention.
Thank you, ma'am. Thank you for a nice presentation. Next, I would like to call upon Dr. Pierre Lal, slot number 6, to give his presentation. Dr. Pierre Lal, Assistant Professor, Banasthali Vijayapet, Rajasthan. I'd like to welcome you, sir, to present this.
Karalan sir, you can present your screen.
Sir, share your side. I feel some technical problem.
Okay, sir. We will share your screen.
Yes, yes, sir. Yes. Sir. Am I audible, sir?
Yes, sir. You're audible. You can start.
The title of my presentation: an optimized investigation on optical characteristics of aluminum gallium nitride nanostructure. The aim of my presentation. This presentation provides a critical contribution in the study of optimized investigation on various fundamental optical characteristics of UV light of aluminum gallium nitride type nano heterogeneous structure. The various fundamental optical properties like UV gain model, UV gain, differential UV gain, and parameter of anti-guiding have been computed by simulating type nano techniques. The spectral behaviors of UV gain with energies and parameters, anti-guiding, and differential UV gain with carriers have also been calculated in this paper. Under the computation in the results, the highest value of UV gain has been achieved at the wavelength of 254 nanometer. The UV light gain of wavelength range 254 nanometer has been very useful in the purification and sterilization type applications. Hence, by this wavelength UV light, the water is verified without any mineral loss. Moreover, it is also utilized to disinfect air and water as well as surfaces. These are heterostructures. Sir, next slide. Next slide, sir. This is optical gain equation. Next slide, sir. This is differential gain equation, and it is measured in centimeter square. Next slide, sir. This is refractive index change. Next slide, sir.
Please come to R&D section.
This is modal confinement factor, and it is a very important role in the modal gain. Next slide, sir. This is anti-guiding factor. It has very important role in the optical gain. Sir, next slide, sir. This is relaxation oscillation frequency. It is measured in gigahertz. Next slide, sir. This is threshold current. It is measured in ampere per centimeter square. Next slide, sir. Now, resultant discussion. First figure represents the graphical behaviors of UV gain with lasing type wavelength of UV photon and peak model type UV gain with densities of carriers for aluminum gallium nitride. In this figure, the UV gain per centimeter with wavelength of UV photon are presented by the left y-axis and the x-axis. Next, the model UV gain per centimeter with carriers density per centimeter cube are represented by the right y-axis and top x-axis. Under this optimization, the spectral performance of the UV gain with wavelength and UV model gain with carriers have been simulated by the help of computational and mathematical techniques. It is clear by UV gain spectra that the higher value of UV gain is achieved at the wavelength of 254 nanometer. This wavelength has been extensively utilized in the applications of purification and sterilization of air, water, and surfaces. So this type wavelength UV light has been more strictly to eliminate the various types of bacteria, viruses, and very harmful contaminants without any mineral loss. This figure represents the spectral behaviors of UV gain per centimeter with the energies of UV photon and differential gain with densities of carriers for both structure. UV gain per centimeter with UV photon energies has been represented by the left y-axis and bottom x-axis, and the differential gain per centimeter square with carrier density has been represented by the right y-axis and top x-axis. The maximum value of UV gain is obtained at the energy value of 4.8 electron volt. And again, the differential UV gain and the anti-guiding parameter with carriers per nanometer cube have been done by using simulations. And last figure, represent the variations in the proportions of parameter of anti-guiding with densities of carriers per nanometer cube and UV gain with the current densities per unit area for proposed nanostructure. And sir, next, sir. NAV conclusion. This presentation provides a substantial and critical contribution in the optimization of innovative study of a computational and investigation on UV gain of proposed under simulation techniques. Under this optimization, the spectral performance of UV gain with wavelength and peak UV gain model with carriers have been simulated by computational and mathematical techniques. Differential UV gain and the anti-guiding parameter with carriers per meter cube have been done by simulation techniques. Under the results, the high level of UV gain has been achieved at the wavelength of 254 nanometer. The wavelength of 254 nanometer has been more utilized in the applications of purification and sterilization of air, water, and surfaces, etc. So this type wavelength UV light has been more effectively to eliminate the various types of bacteria, viruses, and very harmful contaminants without any loss of minerals of water. Next slide, sir. Thank you, sir. Thank you so much, sir.
Thank you, sir. It was nice presentation. We will move next.
I would like to welcome the next participant, R.B. Narmada, student of Kalasalingam Academy of Research and Education. R.B. Narmada, you can present.
Slide. अच्छा म्यूट कर ले, म्यूट कर ले। वो दबाए तो वही बोले बोले slide। वो करने करवा दी।
हाँ तो अगर कुछ नहीं होना है कुछ नहीं।
I request the participant, please unmute, please mute your mic. I request remaining participants, there is, due to time consumption, you have to take 3 minutes. Within the 3 minutes, you can finish your presentation. We will move to the next session. So as much as possible, you can finish within 3 minutes. Okay, thank you.
R.B. Narmada from Kalasalingam Academy of Research and Education can present your screen.
Are you here, Narmada ma'am? Okay, you can present your screen, ma'am. Okay. Ms. Narmada, kindly unmute your. Narmada, are you able to hear my voice? Your voice is not audible, ma'am. Okay, one minute, wait a minute. Next slot, DB Nagamurga from Avadi. Nagamurga is here. Okay, next one. Slot number 9. Mahata Vosha from Saurashtra University, Rajkot.
Hello.
Yes, ma'am. Audible, ma'am.
Yes, sir. Am I audible?
Yes, audible.
So,
Clearly.
so can I start my presentation?
Yes, ma'am. Carry on.
Okay. Okay. First of all, good afternoon. So the title of my presentation is Structural, Dielectric and Raman Studies of Sphero-Cobaltite Microcrystals. These are the plan of my presentation. Introduction of sphero-cobaltite microcrystals. So sphero-cobaltite, popularly known as cobalt carbonate, is a mineral belongs to calcite group. This is the crystal structure of sphero-cobaltite and it's have a hexagonal crystal structure. These are the applications of the material. This is the synthesis method. Using the hydrothermal method, we synthesize this material. In this method, we took 0.6 gram cobalt chloride and some amount of CTEB and urea were dissolved in 16 ml distilled water under continuous stirring. After that, the produced mixture transferred in Teflon-lined autoclave and maintained at 160 degrees Celsius for 5 hours. And after that, precipitated cobalt carbonate was centrifuged with distilled water and ethanol. And after that, dried in an oven 60 degrees Celsius for 24 hours. And after that, we got final product, cobalt carbonate microcrystals. This is the powder XRD plot. From the powder XRD plot, we observed that there is no impurity phase detected in XRD plot, and the diffraction peaks are very strong and sharp. These indicate the good crystallization of the materials. This is the unit cell parameters of the sphero-cobaltite microcrystals. This is the DFT data. From the DFT data, we conclude that the experimental data and theoretical data both are in good agreement. This is the FSM images. From FSM images, we concluded the majority of particle size in observed area fall within the range of near about 29 micrometer with needle shaped morphology. Impedance study, this is the impedance plot. From the impedance or Nyquist plot, we suggest that the center of semicircular arc is below the real axis. So it suggests the non-D type relaxation behavior. It shows only one semicircular arc. So it suggests that the contribution from the grain only, and these are the value of RGCG and conductivity. From the modulus plot, we also conclude that the only grain effect only. This is the dielectric constant. Dielectric constant decreases as the frequency increases. This is due to the rotating dipole cannot compile the variation with higher frequency of the applied field, and hence the polarization decreases and the value of dielectric constant decreases as the frequency increases. Similarly, the dielectric loss, the value of the dielectric loss is also decreases as the frequency increases. This is the Johnson's plot. From the Johnson's plot, we found the value of the parameters n and a respectively. The value of n indicate the hopping motion involve the translation motion with sudden hopping of charge carriers. This is the conductivity plot. The conductivity plot shows the low frequency related to accumulation of the charge carriers, and the value of the conductivity gradually increases as the frequency increases. This is the Raman spectroscopy. From the Raman spectroscopy, we observed the total 4 peak at 199 centimeter inverse, 304 centimeter inverse, 725 centimeter inverse, and 1084 centimeter inverse. So in this, we mentioned in bracket the value of Raman peaks found from the DFT calculation, and which are good agreement with the experimental data also. The vibrational modes can be categorized into 2 ways, that is the internal and external vibrations. The lattice vibrations associated with lower wave numbers, Raman peak, that is 199 centimeter inverse and 304 centimeter inverse, represents the translation and vibrational optical modes, while the other 2 peaks represent the asymmetric bending and symmetric stretching of carbonate ions. The experimental and theoretical Raman modes are well matching with previous reports also, and confirms the formation of cobalt carbonate microstructured material. So the conclusion of this, this presentation is the sphero-cobaltate microcrystals are successfully synthesized via hydrothermal method. The powder XRD study confirmed the hexagonal crystal structure with these parameters, and are in good agreement with the DFT calculations also. The FSM images confirm the micro size of the particles with needle-shaped morphology. The impedance and modulus plot suggested the contribution of grain only within the frequency range study. The dielectric analysis suggested decreases in the values of decreases constant and loss with increasing frequency. In the Johnson's plot, the frequency exponent value indicated the hopping motion involved the translation motion with sudden hopping. The Raman analysis suggested the asymmetric bending and symmetric stretching of carbonate ions with consistent with previous present. The experimental and theoretical Raman modes are well matching with previous reports and confirms the formation of cobalt carbonate microcrystals. This work already published in Journal of Material Science and Materials in Electronics with high impact factor. Acknowledgements, Dr. Mihir Joshi is my PhD guide, and Professor P.K. Jha from the MS University. I done my DFT work with P.K. Jha sir. Lab members, and thank you for your kind attentions.
Thank you, ma'am. It was nice presentation.
Thank you, sir.
Is there any query from audience? No. Okay, ma'am. Have you tried any recent application related?
Thank you. What? Please pardon, sir.
Have you tried any application part?
Actually, my work is going on, so I am trying to the application of this material is enhance the power of the lithium-ion batteries. So I am working on it right now.
Okay, ma'am.
Okay, thank you, sir.
Okay, ma'am. Thank you, ma'am.
Yeah. Thank you very much.
Okay, next one. Slot number 12. Ayman Tilili from Faculty of Science of SAFES, GAFSA.
Good morning, sir.
Good morning.
First of all, thank you very much for giving me this opportunity to attend this conference. Big thanks to each and everyone present here today. Let me just starting by introducing myself. Let me just starting by introducing myself. My name is Ayman Tilili, PhD researcher at the Faculty of Science of the Faculty of Science of SAFES, Department of Chemistry. And what I would like to present to you today is an analysis of a new zero-dimensional antimonium organic inorganic hybrid material synthesis and characterization. In my presentation, I will focus on 4 major issues. Point 1 deals with introduction. Point 2 deals with synthesis and the methods of analysis. Then I will move to structural study and physicochemical characterization of the synthesized compound. And I will end my presentation with a conclusion. Hybrid compounds have aroused the interest of a large number of researchers due to their interesting physicochemical properties. The interest of this material lies in the combination of the properties brought by organic molecules such as flexibility, luminescence, and the inorganic molecule like conductivity, thermal stability. The cohesion of this compound is assured by either hydrogen bonds or van der Waals bonds. Hybrid materials with the general formula AXMYXZ exhibit optic electric magnetic properties, and thanks to this property is used in different fields such as electronic medicine, optic, and the environment. In this part of my presentation, I would like to talk about the synthesis of this compound. C3H5N2SSB4 chloride single crystals were synthesized by slow evaporation at room temperature of a solution of 2-aminothiazole and antimony 3 oxide in concentrate HCl and a minimum of ethanol. The solution was mixed for 20 minutes and was kept at room temperature. After several weeks, colorless and prismatic single crystals were appeared, which were filtrated and dried in air. These single crystals were characterized using X-ray single crystal. A vibrational study was carried out using FTIR, optical absorption measurement, and NMR studies. After the X-ray single crystal studies confirmed that the crystal belongs to the triclinic system with the centrosymmetric space group P. The structure showed that the 2-aminothiazolium cation are bound to sp2cl8 dimers through hydrogen bonding. Organic cation contribute to the stability and cohesion of the crystal structure through hydrogen bonds of the NHCl Cl type. This result was confirmed also by the Hirschfeld analysis. The analysis of 2D fingerprint of the surface of the molecule according to Hirschfeld surface method indicate that the most intermolecular interaction abundant in the crystal packaging was CLH with 52.6%. The X-ray powder diffraction shows the superposition of the theoretical and the experimental diffractograms. This superposition confirms the phase purity of the sample synthesized. After examining these points, let's turn to the vibration study. The FTIR proved the presence of organic parts. The band observed at the 3,221 centimeter -1 is assigned to the vibration of NH3+. The deformation in H2 stretching mode mode is detected at 1617 centimeter minus 1, and the vibration of C in H2 is located at 1341 centimeter minus 1. The UV absorption show two absorption band located at 263 and 234 nanometer. The higher energy absorption band can rather be assigned partially to ligand to metal charge transfer. The lower energy can be attributed to the excitonic absorption. Let's now take a look to NMR studies. The carbon 13 NMR spectrum of the title compound shows two peaks. The first at about 107 ppm. This peak corresponds to aromatic ring of organic molecule, and the second peak located at 40 ppm are granted to solvent dimethyl sulfoxide DMSO. The proton spectrum shows the three peaks at 6.85, 7.25, and 9.1 ppm. The signal originated to NH2 was observed at 9.1 ppm. CH proton gives a resonance at the value set 7.20 ppm. However, CH5 proton gives signal at more downfield region. The peak appears at 6.85 ppm. This brings me to the end of my presentation. I would like to run to the main points again. The compound crystallized in the triclinic system at the P1 bar space group. The material cohesion of the compound between the organic group and the inorganic group layer is assured by an HCl hydrogen bonds. Infrared spectroscopy proved the presence of organic part. The optical properties were investigated by UV spectroscopy, showed that the compound shows at the UV region Weeks luminescence. And the NMR result is in agreement with the crystallographic data. Thank you for your attention.
Thank you, ma'am. Nice presentation. Okay, next.
Yes.
Thank you, ma'am. Thank you for your presentation.
Thank you. Thank you very much.
Yeah.
Next, I call upon.
Dear participants, please start from your result and discussion part and coming to conclusion quickly. Yes, we have only 3 minutes. We have less time, so please.
Thank you, Dr. Balaji. Next, I call upon slot number 11.
Yes, sir.
Dr. Vasumati from Thuthukudi. Can you share your screen, ma'am?
Yes.
Okay.
Good afternoon, everyone. Hello.
Yes, ma'am.
Hello.
Yeah, you can proceed. Please start from the result and discussion part and specify the important points which can come to.
The title of my work is characteristics. Materials and methods. Urea phosphoxalic acid crystals were grown by solution ratio was prepared. Seed impression technique was used to obtain peak-sized crystals. Once such a crystal is displayed. The signal XRD data. The structure of urea phosphoxalic acid crystal is monoclinic. The lattice parameters are ABC
alpha, beta, and gamma. Volume of unit cell is AP sin beta equal to 437.5 angstrom cube. TGDT analysis. The temperature range 35 degrees Celsius to 165 degrees Celsius indicates the first stage in which the sample is thermally stable. The temperature range from 165 degrees Celsius to 240 degrees Celsius is the second stage in which the decomposition occurs. The temperature range 240 degrees to 400 degrees Celsius indicates the third stage in which about 25% of weight loss of the sample is seen. UV visible spectral analysis. The UV visible spectrum of urea phosphoric crystal in the wavelength region from 170 nanometer to 1100 nanometer. Cutoff wavelength is 206 nanometer. We can see the relation between UV visible absorption and wavelength of urea phosphoxalic acid crystal. Using tau plot, optical band gap is Eg equal to 6.01 electron volt. Hence, our crystal is an insulating material. EDAX analysis. EDAX spectrum of urea phosphoxalic acid crystal shows the presence of carbon, nitrogen, oxygen, and phosphorus. SEM analysis. From the figure is observed that surface is smooth and free from cracks. However, very few microcrystals are seen on the surface. Conclusions. Urea phosphoxalic acid crystal was grown by slow evaporation solution growth technique. The grown crystal crystallizes in monoclinic structure. The TGDT studies elucidated the decomposition and confirmed the thermal stability of urea phosphoxalic acid crystal. The cutoff wavelength of UPOA crystal was found to be 206 nanometer and optical band gap is 6.019 electron volt. The carbon, nitrogen, oxygen, and phosphorus peaks were present as expected from UPO crystal. Surface analysis for the chrome crystals were done by SEM. Thank you, sir.
Thank you, ma'am. Any questions from audience? Okay, ma'am. Thank you. Next.
Next, I call upon Pritima K, RMD Engineering College, Chennai. Okay, next. Slot number 14, Dr. Divya Vilpula, JNTU Hyderabad, Telangana. Is here? Pratima is here.
Yes, sir.
Pratima,
Yes, sir.
now you share your screen. Ma?
Yes, sir. I'll share it.
Okay, carry on.
Is it visible, sir?
Yes, ma'am. Visible.
Good afternoon to one of us present here. I'm K. Pratima from RMD Engineering College, the first year. And this is a review on solar cells yesterday and today presentation. And the co-authors are Shaikanya, Sharmita T, Lakshmi Babita, Surya, and our professor, Dr. Priya ma'am. So these are the contents of our presentation. So due to the shortage of time, I'll just skip the first two slides. So there are basically three types of generations. The first generation of solar cells, second generation, and the third generation. So the first generation, it includes a single crystalline and polycrystalline one. And the second generation, it includes amorphous silicon, cadmium telluride, and copper indium gallium selenide. Whereas in the third, it is really high. So it is organic solar cell, perovskite solar cell, etc. In 1954, the Bell Laboratories developed the first silicon solar cell, which had an efficiency of 6%. The earliest commercial silicon, which was made of silicon, are currently the most efficient solar cells available for residential use, and these account for about 80% of all the solar panels sold around the world. Solar cells in yesterday's time. The energy requirement of the mankind is growing continuously till date. The annual solar potential in Earth is 23,000 terawatt-year, and 16,000 terawatt-year should be the world energy consumption for 100 years, as computed in a yearly consumption in 2009. So the usage of the solar energy did not start yesterday or before yesterday. It is starting from the ancient, and people also used it for several uses. So they concentrated the waves of the sun for use for lighting fire, and also in more advanced in the 3rd century BC, the ancient Greeks and Romans used mirrors to concentrate the sunbeam for lighting torches. So from industrial revolution to the age now, John Ericsson, who is a Swedish-American inventor, was also devoted to the development of useful power from solar energy. In 1873, he invented a displacer type engine, which was working upon the sun rays collected by the parabolic reflector. By this engine, he demonstrated that power can be produced by solar energy alone, without the intervention of the steam. You can see the picture of his invention. The world's first commercial concentrating solar power plant, the Planta Solar 10, was set up in 2004 near Celebes, Spain. So coming to the spectrum of solar radiation, the solar spectrum has a range of 100 nanometer to 1 millimeter, but most of the irradiance is occurring between 50 nanometer to 2500 nanometer, with the maximum in the visible region like 400 to 700 nanometer in air mass. So this means that the solar cells should strive to absorb as much in the visible region of solar spectrum as possible. First generation photovoltaic cell. So in 1936, Ruzael Ohl was the inventor of first generation photovoltaic cell. So this cell consists of a large area, single crystal, single layer of PN junction diode. The cells are typically made of the fusion process with the silicon wafers. This is one of the oldest, and till date, this is one of the most efficient and the popular solar cell used. So commercial production of CSI modules began in 1963 when Shao Corporation of Japan started producing commercial PV modules and installed a 242-watt PV. So this also works under the photovoltaic effect. So after Becquerel, Heinrich Hertz noticed in 1877 that electrodes illuminated by ultraviolet light emitted electric spark. This marked that discovery of the photovoltaic effect. So after that 20 years, Albert Einstein defined light as photons. So the second generation cells are thin film technologies that are often commercially available, such as copper indium gallium selenide, cadmium telluride, and gallium arsenide, and amorphous silicon. You can see the efficiency of the second generation has been improving years. The third generations nowadays are commercial and more advanced technologies. These include the organic photovoltaics, perovskites, and etc. So when we compare the efficiencies of all the three generations, the first generation had a solar efficiency of cell lab-based is 24.7%, and the module-based is 22.7%. Whereas the second generation, compared to the first and the third, it has less efficiency. It was only 18.4% in the lab-based, and module-based is 13.4%. The third generation has a very high efficiency of greater than 30%. You can see the third generation solar cells and also the efficiency of the three generations in the graph represented here. Solar cells in today's time. Scientists are discovering new ways to decrease the cost and increase the efficiency of solar panels and coming up with creative, impressive ways to generate power. So these are a few examples like perovskite, thin film solars, and etc. And also in perovskite, the efficiency has been rising from 3.8% to 25.2% within a decade, and it is continuously rising. Here are the few pictures where you can see the solar panels have been installed in different ways, like in the top of the train, on top of the plane, and also etc. Alternate solar material. So the primary goal was to show that an inexpensive solar cell made of cheap materials does exist. Becquerel's initial experiments and copper-26 Cupar oxide cell in salt solutions offer the fundamental for our cell. This paper is mainly concentrated on the production of low-cost electrolytic cuprous oxide solar cell, which can serve as the alternative to solar-state solar panel. So the initial discovery which showed that the light sensitivity of oxidized copper was demonstrated by W. Haeckel in 1877. Goy and Regault in 1888 reported that copper oxide on one of the two copper plates in a solution of a metal chloride was very sensitive, even at a low light intensities. By illuminating the copper oxide electrode in sodium chloride solution, they produced a potential of 0.1 volt. And the wavelength was observed to be 5,000 angstroms. The electric current was also found to be proportional to the intensity of the light to a certain extent. And Goldsman and Brodsky also noted certain observations like using oxidized copper electrodes in sodium chloride solution. They were able to show that the photovoltaic effect and also the magnitude of the current was independent of the concentration of the solution. So where can this be implemented as a question? So this can be implemented in the salt water bodies. Like our Mother Earth has been gifted us with 61% of salt water in terms of ocean. All the water bodies are now a potential solar cell because if we immerse the copper and cuprous oxide solar cell in them, and due to the photovoltaic effect, we are able to harness a large amount of solar energy and convert it into electrical energy. Thus, it can also be done on ships and boats for the production of electrical energy. So the advantages are these are of low cost. So 1 square meter of this is going to cost around 367, whereas 1 square meter of silicon solar panel is going to cost around 912. So you can see how much is the difference between them. It is also of great availability and it produces 500 microampere current at 0.25 volts and is also non-toxicity, so it is eco-friendly. And this photovoltaic material, because of its high absorption coefficient in visible region, it is also one of the attractive material. So efficiency of the solar cell is also being figured by the temperature. So the temperature of the solar panel is increasing, then the efficiency of the solar panel decreases. So these are the few methods where we can prevent this overheating, like the using of the PCM at the back of PVL and using setup for air cooling and the thermolytic cooling. So in the graph here, you can see the efficiency of the solar cells have been increasing greatly. And also the people supporting for the expansion of this has also been increasing. So innovation. So solar power is a constant state of innovation since 2019 with the new advances. Last year alone, there have been milestones in solar efficiency, solar cell energy, wearable solar technology, and solar design technology. So there are basically two types of solar technology. One is photovoltaics and concentrated solar power. So with these are the advantages like solar tracking mounts, solar water purifiers, etc. So here comes the idea. Why should we waste water like carrying this in the water tanks, which always leakage and wastage of money as well as resource. So for watering the plants in and around the area and the public places, instead of that, we can use solar energy, solar panels. So your question may be, how can a solar panel produce water? Yes, of course, a solar panel can produce water as well as electricity simultaneously. So this can be installed in the roadsides as well as also in the agricultural field, where it provides water as well as electricity for them. So 1 square meter of this is going to produce 1.64 liters of water for 1 hour. So this can be done just by installing the MSMD device, which was invented by Peng Wang, directly underneath the solar panel, so that the system occupies the same footprint as the solar panel. And the solar cells can only convert 20% of the sunlight into electricity, whereas 80% is of heat. So this heat can be condensed into water and be supplied. So we can also attach the moisture sensor so that it can detect the moisture in the soil. So once the moisture content is adequate for the plant, it can be taken in tubes to different tanks so that it can be used for different purposes, because this is one of the pure water. It can also be drink purpose. So, and then it can also be used in construction works, because at the first they are not provided with the electricity, and also they need water for setting up the concrete for several days. So you can see the graph where it will be decreasing in 2050, the cost, and also installation in the different parts is being increasing. So conclusion is that from a thorough literature survey, we have concluded that it is one of the most efficient and the fastest growing industry. So in the immediate future, silicon solar cells are likely to continue to decrease in cost and be installed in large numbers. And already in the United States, these cost decreases are anticipated to increase the solar power produced by at least 700% by 2050. These cells are still mostly too expensive and difficult to make commercial use, but ongoing research may one day make implementing these super efficient cells. So here I would like to thank my professor Priya, Dr. Priya ma'am, and also a HOD, Dr. Maria Susail, and also our beloved principal sir, Dr. N. Anbichulian sir, and also my co-authors, and of course our college, RMD Engineering College, for providing this wonderful opportunity, and also the conference coordinator for providing me an opportunity to reviewing my views. Thank you so much.
Thanks, ma'am. Thank you for your.
Thank you, ma'am. Nice presentation. Next, I would like to call upon Dr. B. Sarvanakumar sir to present.
So good afternoon to one and all. My voice is clear, sir.
Yes, sir. It's audible.
Sir, please give the permission to present my screen.
Do not share my screen, sir. Host disable the participant screen sharing. So can you search my another name, sir? Dr. D. Saravana Kumar.
Yes, sir, just a
Admin, that name is admin, sir.
Saravana Kumar, sir. You can present your screen now, sir.
Sorry, sir, but sir, host disable participant screen sharing. I got that message, sir.
Sir, excuse me, Saravana Kumar, sir. I think there
Sir,
is
I
a
can't share my
problem.
screen, sir. I can't
Okay,
share my
okay, sir.
screen.
Okay, sir. You can share, sir.
Now I raise my hand, sir. Check my panel.
Okay, okay.
Please give the permission to share my screen, sir. Yes, yes. Good afternoon, Ananda. So my topic is copper oxide decorated zinc oxide on multi-volt carbon nanotube nanoparticles and its morphological characterization. So the precursor materials are zinc nitride dihydrate and copper oxide. The matrix material is multi-volt carbon nanotube. So these the cupric chloride and zinc nitride is a mother solution to make the mother solution with multi-volt carbon nanotube. So the combined solution actually it is stirred again rigorous for 2 hours at 60 degrees Celsius. The mixture was cooled to ambient temperature. Afterward, the mixer solution was poured into the 50 ml wells cleaned with a jet nebulized bottle by spraying a copper plate with dimension of 10 into 8.5 centimeters cube. So next slide, sir. So this is the preparation method. In this method, a copper plate with dimension was 10, 8 to 100 degrees Celsius was mounted onto a hot plate oven for 4 hours. After spraying the hot copper plate with a sample was cooled at room temperature. The sample was solid powder and also we can make the thin film by using this simplified spray pyrolysis method, which is cost effective one. The students can do the project by using this method in a simple way. So this is the simple method. The next slide, sir. So regarding this XRD spectrum for this entitled sample, actually we have observed that myself and the doctor is Raja Karthigan from Tyagaraja College, the as-prepared copper oxide, zinc oxide carbon nanotube thin films were annealed at 3 different temperatures to study the change in crystal orientation and dislocation of nanocrystal. The notable change were observed in the crystal temperature at 300 and 600 degree, denoting phase transition, whereas the intensity of peaks varied considerably at 600 degrees Celsius, denoting a significant increase in crystallinity. The XRD potents at all temperatures were comparable for the 3 film samples, with all peaks assigned to the JSPDS number relevant to JSPDS 5 number 36 or 1451. Now, so the CO is corresponding JSPDS file number 800076, and then multi-volt carbon nanotube is associated with the JSPDS number 261076 respectively. The film annealed at 600 degrees Celsius was highly crystalline with an average crystalline size. Next, sir. So this is the gaze sensor studies. Actually, I have another one presentation. For some interruption. I can't technically say I can't present my overall slides. So regarding this gas sensing studies, a thin film substrate was prepared under a pressure of 15 megapascal, and gold lead was mounted on both sides of the substrate to form the sensing element. The element was enclosed in a quartz tube, which was heated to a certain temperature in a tubular furnace. A constant current was applied across the element. The steady state resistance of the element was measured in the air and in the presence of a target gas in the air. So ethanol sensitivity was defined as ratio of sensor resistance in the air to that in the air gas mixture. So we know that. So the substrate was kept at a constant temperature using a flat burner heater, and temperature was monitored using chromium aluminum thermocouple. The gold and aluminum electrodes placed on the surface of the pellet made ohmic contact with the pellet and acted as resistance measuring electrode. Initially, the chamber was evacuated to base pressure. So finally, the findings of this study, the entire system was covered with a glass chamber, and then the sensing analysis were done. The oxide material has high reactivity toward reducing the gases at relatively low operating temperature, ability to easily absorb oxygen and its surface because of its natural non-stoichiometry character. Next, sir. Next slide. So this is one of the another one application study on photocatalytic activity. The mechanism of a photocatalytic degradation for the untreated compound which is depicted here. This is the mechanism picture. This depicted picture clearly shows the degradation mechanism of rhodamin B on the part of this sample composite under ultraviolet lamp irradiation. The photocatalytic activity of the sample was examined by rate of degradation by rhodamin B under the effective of UV radiation. All photocatalytic reactions were performed in photocatalytic reactor system, which consisted of a cylindrical borosilicate glass reactor vessel with a volume of 200 ml, a cooling water jacket. So we know that the photocatalysis is a reaction which uses light to activate a substance which modifies rate of chemical reaction without being itself involved. So these three samples were evacuated from degradation of rhodamin B dye solution under visible light irradiation. From the spectra, it is clearly found that actually some technical issues I can't present that slide. So sorry for inconvenience. From the spectra, that the dye solution is achieved within 60 to 70 minutes. After 60 minutes of irradiation, C by C0 reduced almost to 0. So it is an evidence for the complete degradation of the dye solution. It was found that the precipitation and the annealing treatment method was prepared this sample so high photocatalytic efficiency. So this sample is prepared at room temperature and the various temperature range like 300 degrees Celsius up to 600 degrees Celsius, where C0 is the initial concentration of dye. So, and C is the concentration at a time. Okay. So also carbon nanotube, multi-volt carbon supported to increase rate constant for the photodegradation of this dye. So the copper oxide, copper and zinc ions will serve as mediators of the transfer of interfacial charge at a proper doping concentration. The activity evaluation shows that the presence of small amount of multi-volt carbon nanotube can enhance the activity. So conclusion. So copper oxide doped zinc oxide carbon nanotube were synthesized using spray cost-effective modified spray pyrolysis method and annealed for different annealing temperature. The prepared samples undergo various characterization, particularly the FTR and some vibrational studies for which confirms the functional group, metal oxide functional group. As the copper oxide dope, this nanocomposite exhibits superior photocatalytic activity against rhodamin B dye from the excellent gas sensitivity and also the electrical property like mobility and photocatalytic properties. Expect that this nanocomposite would be an efficient material for the medical field, harmful gas handling management, and for the purification of water. So thank you so much for giving this opportunity. Thanks to all.
Will be ready for
Thank you, sir. Thank you for the presentation. Okay. Is there any questions from the chairperson, sir? Any questions? Okay. The next presenter. Now I would like to call upon Rafiq Mullah, postdoctoral research scholar from Swansea University. Swansea University. Sir, I request you to present your presentation, sir. Due to time consumption, you will take just 5 minutes. Sorry for the inconvenience, sir.
Yes, sir. Yes, sir. No worries,
Okay.
sir. Thank you.
Thank you, sir. Thank you.
Sir, thank you for the opportunity. I hope my screen is full.
Yes, sir. Yes, sir.
Thank you,
Yes,
sir.
it's visible.
Thank you for the opportunity. Here I'm presenting my topic, electrical energy from pencil traces. And in this presentation, I will briefly introduce about thermoelectric materials, then directly go into the pencil trace as a thermoelectric material of our work. So thermoelectric materials. So the word thermoelectric indicates thermo and electric, means conversion of thermal energy into electrical energy from using some materials. They are known as thermoelectric materials. So when a temperature gradient is applied on a conductor, the charge carriers move from hot side to cold side of the conductor. Then they generate some electric potential, and that electric potential is directly proportional to the temperature gradient applied. And these materials can be used to convert waste heat into electrical power. And typically people use N-type semiconductors and P-type semiconductors, and they are connected in a junction mode, PN junction. And each PN junction will produce few millivolts of electrical power. So for practical applications, so such PN junctions are connected in series so that a higher voltage can be produced for the practical use. So the present challenge is the materials which are used for the applications or toxic materials like bismuth telluride and lead telluride. So these are having toxic elements like lead and tellurium. They are scarce and difficult in processing and expensive raw elements. So in order to avoid these things, we are working on low-cost thermoelectric materials. And one of the recent work, what we are trying in our research is the pencil trace, using the pencil trace as a thermoelectric material. So when we use pencil trace as a thermoelectric material or a conductor, so when we apply temperature gradient on pencil trace, we can use it as a thermoelectric material. So basically, we need a N-type and P-type material. So we try to convert the same pencil trace into a N-type material. Basically, it was a P-type material when it was a pure pencil trace, and we converted that pencil trace into N-type material by treating it with a polyethylene amine polymer. So we have both N-type and P-type material from the pencil trace, and we have designed a 5 PN junction device. So it has a 5 PN junctions. So, and we can characterize by applying temperature gradient across the device, just like the image what I have shown here. So these are the real images of the device. So you here in the figure C, you can clearly see the shining and dull thermoelectric traces. So shining one is P-type and dull one is N-type, that is treated with polymer. So it is also very flexible device. So it is just common Xerox paper on which we have developed a patterned our device, and it is quite flexible. It can be attached on any curved surface or even for any type of hot surfaces, so that we can extract heat from the surfaces to convert into electrical power. So this is just we are trying to see the reproducibility in the device by bending the pencil trace and measuring the different thermoelectric parameters. So these are the SEM images of the pencil trace. This is the normal paper without any pencil trace. So these two images are the pencil trace on the surface of the paper, and these are the after treating with polyethylenamine. We can see the fibers of the papers are covered with the pencil traces completely. And this is just to confirm whether there is a nitrogen doping into the graphite happening or not. So by doping with nitrogen, graphite can be converted from P-type to N-type. That has been confirmed by XPS measurements. And finally, we have studied the performance of the device. We applied temperature gradient across the device. Then for different temperature gradients, we have seen different increase in the voltage production from the device. You can see the red dots are the voltage development from the device at different temperature gradient, and the square black boxes are the current increase in the current of the from the device upon different temperature gradient. So maximum we observed about 99.2 millivolts voltage generation from the device what we have prepared. It is a 5-junction device, so we can increase the junctions in order to get better voltages from the device. And the maximum power output of the device was about 1.75 nanowatts at about 60 degree Kelvin temperature difference. So to conclude this, here the present study demonstrates a facile and novel approach to produce graphite-only thermoelectric generator using ordinary pencil trace on Xerox paper. And further improvements are possible by treating graphite with different materials or allowing it with different elements. The work demonstrates that the ordinary pencil traces on paper may be used as the foundation for cheap, flexible, and easily disposable, environmental friendly thermoelectric material. Thank you everyone. Thank you, sir.
Thank you so much, sir.
Thank you, sir.
Thank you so much for your presentation. There are remaining 6 more participants are there. Due to the time consumption, we have a lack of time today. So it will postpone to tomorrow. Remaining 6 participants, you can present your presentation tomorrow 11:45 a.m. All the participants be ready for tomorrow 11:45 a.m. because we have to start the second session today. First of all, I would like to thank our chairpersons, Dr. Balaji sir and Dr. Sakti Pandey sir, for sparing the valuable time with us. They have been waiting for, they are evaluating the oral presentations. Thank you, sir. Thank you so much, Dr. Balaji sir and the Sakti Pandey sir. Thank you so much, sir. All the participants are requested to stay here. We will start the second section of the day within a minute. Once I remind you, the remaining participants, 6 members are there. You will present your presentation tomorrow 11:45 a.m. after the session is over. We will give you the time for you, so you can present tomorrow. Yes, we have successfully completed a morning session. We have from Cambridge University scholar Vinod Babu. You had a lot of points, lot of knowledge, information from the sessions. I hope you all happy with that. Today, we will start the second section, that is poster presentation. Before that, you can have one more lecture given by the chief guest. The success of your presentation will be judged by not by the knowledge of you send, but what the listeners receives. According to that, you can evaluate your presentation. Okay. Once again, I gladly welcome you all to this international conference for the afternoon session. We will start the afternoon session. Now I would like to call upon Dr. M. Silambarasan, Assistant Professor, Department of Physics, to introduce the chief guest. I request Dr. M. Silambarasan, sir, to introduce the chief guest. Let's wait for a couple of minutes. The chief guest is arriving now. Within a minutes, we will start the session. I request all the participants stay here. Yes, we are living in a postmodern world and we are living in the materialistic world, as we know that. In this contemporary world, we are afforded by the technology. Without technology, we are living in the nowadays. Imagine that. So the title Advanced Materials Science. The materials will give you the new innovations. For example, we invented mobile phone, laptop, all the things. Because of, if you invented in the new materials, you can we can improve our technology. Technology will give us improve our civilizations, our knowledge. For that. Okay. I request all the participants be ready for the next session. Okay. I welcome our chief guest, Dr. Elite Selvi ma'am. She join us. Now I would like to call upon Dr. Silambarasan to give the chief guest introduction.
So good afternoon, everyone, and warm welcome you all at session 3 of ICAMS 2021. Honorable dignitaries, it is my tremendous honor to introduce our chief guest for the session 3 of ICAMS 2021. Dr. V. Elite Selvi Madam is a principal scientist at CSIR National Physical Laboratory, NPL, New Delhi, India. From Bharatiya Niteshak Dravya Indian Reference Material Division. She is an assistant professor in academic CSIR. She received her MSc in chemistry from Gandhiram Rural University, Tamil Nadu, India. She was awarded MS PhD in materials engineering from Indian Institute of Science, Bangalore. So currently, her work is in the area of chemical metrology, focused on the development and certification of cement and building materials and wheat B&D standards. Also, her interest is focused in the area of water purification, exploring green absorbance and natural zeolites for removal of organic impurities such as phenols and ammonia from water. She started her research career in 2004 at the Surface Engineering Division, CSIR, National Aerospace Laboratories, Bangalore, and worked there for almost a decade and a half with incredible contribution in the field of corrosion science and engineering, and then moved to CSIR NPL New Delhi. She has worked extensively in the area of eco-friendly anti-corrosion coating for lightweight magnesium and aluminum alloys by micro arc oxidation and chemical conversion methods. Her work in the CSIR translation project for the development of eco-friendly anodization coating for aircraft aluminum alloys has resulted in the development chromic acid free coating. So also developed chromate free cerate based conversion coating on zinc nickel coating steel as a replacement for chromate passivated cadmium coating for aircraft components. Dr. Ilichelvi Madam research interest also include electroless, electro deposition of Ni and cobalt based alloys replacement of hard chromium coating. She has nearly 21 international publications in peer-reviewed journals and has presented her work in several national and international conferences. She is a reviewer for several international journals. Dr. Ilichelvi Madam has many awards to her credit: CSIR Research Indian Diamond Jubilee Award in 2004, CSIR NALS for Best Women Scientist Award and Best Innovation Award Team 2016-2017. She is presently guiding 4 PhD students from ACSIR and has guided several MTech and MSc students for their project work. The presence of such a personality in ICAMS 2021 is a really blessing. So thank you for this opportunity.
Thank you, sir. Thank you for giving the introduction of chief guest. Now, I would like to call upon our honorable chief guest of the day, section 2, Dr. V. Tamilchelvi ma'am, to deliver her lecture. Science is a way of thinking, much more than it is a body of knowledge. Everything is theoretically impossible until it is done. Yes, is visible. Once again, wish to welcome our honorable chief guest, Dr. Lalit Chelvi ma'am. Lalit Chelvi. National Physical Laboratory from New Delhi to deliver her lecture. Ma'am, shall you start the session, ma'am?
Hello.
Yes, ma'am. We can hear you. You can start the session, ma'am.
Hello.
Yes, yes.
I'm audible?
Yes.
Hello.
Yes, ma'am. You are audible. You can start your session, ma'am.
Hello.
Yes, ma'am. Yes, ma'am.
I'm audible now.
Yes,
Yeah.
ma'am. Yes, ma'am. You are audible.
Yeah. I'm
you
not
can start your
hearing
session,
anything.
ma'am. Okay.
Pardon? Yeah.
You can start your session, ma'am.
Yeah. Thank you very
Okay,
much.
thank you.
Thank you very much for the introduction.
Thank you.
Actually, I'm Dr. Lalit Chelvi. Now, my presentation topic is the proficient utilization of electrochemical techniques to understand the corrosion mechanism of oxide coatings on magnesium alloys. So in this presentation, I'll be discussing the two aspects. One is the development of a micro oxidation coating, oxide coatings on magnesium alloy. And second one is the electrochemical techniques utilized for the evaluation of this developed oxide coatings. So next slide. So in recent years, these magnesium alloys are most interesting material in the aerospace and automotive industries because of its lightweight. So it is most critical for the weight reduction. The density is very low and it is around 1.74 gram per centimeter cube. It is around 75% lighter than steel and 35% lighter than aluminum. So in addition, it is also having the excellent property of high strength to weight ratio and stiffness to weight ratio. So it is the most widely used in aerospace industries. So next slide. So we can see.
Ma'am, excuse me, ma'am. Sorry for the interruption, ma'am.
Yeah.
We can't see your face clearly. Please turn down your camera slightly, ma'am. Slightly down your camera, ma'am. It's not a visible full face.
Actually, I am sitting in the room where light is very
Okay. Now it's visible, ma'am. Yes, ma'am. It's visible now.
Oh, now it is visible?
Visible, ma'am.
Okay.
Okay, thank you, ma'am.
So we can see some of the applications of this magnesium alloy in aerospace industries. So German Lockheed helicopter is aircraft is completely made from magnesium alloys. And other parts like aviation segments, aircraft doors, and other helicopter components are widely made from the magnesium alloys. So next slide. Next. So in automotive industries, back. So in automotive industries also, the several internal components are made from this magnesium alloys, and mainly magnesium wheel hubs are most widely used. And the GM General Motors have developed the lightweight magnesium alloys, and it is also having good corrosion resistance property. So recently it is the applications of these alloys are very much increasing. But if you are telling next slide. So, but if we see the usage of these alloys is not complete as we are seeing for aluminum in different applications because of its poor corrosion resistance property. So it is very much poor. Next, having a poor corrosion resistance behavior due to its several factors, like it is a most active metal in the EMF series, and it is having the reduction potential of -2.36 volt. So it is the most anodic metal. when it is in contact with any of the other metals above in the seals, in the presence of corrosive environment, it undergoes severe galvanic corrosions. So the corrosion is the most dangerous part for the magnesium alloy. So next slide. This magnesium also follows the phenomena of negative difference effect. So this is the only metal that follow this phenomena, and negative difference effect is nothing but the difference between the hydrogen evolution rate at open circuit potential to the hydrogen evolution rate at the anodic polarization potential. It is nothing but the difference between the current at open circuit potential minus current at the anodic potential. So generally, when any metal is immersed into the corrosive environment, it will, or any electrolyte medium or any moisture content, it will undergo dissolution and form metal 2+ ion with evolution of electrons. So that is the anodic reactions. Whereas in the cathodic reaction, these electrons are utilized by the H+ ions and it forms a hydrogen evolution takes place. So it is the anodic. From here in the graph, we can see this solid lines. When these metals are polarized, this solid line, we will obtain the symmetrical solid line graph. So the cathodic current and the anodic current are equal. Whereas when magnesium alloy is polarized in any of the medium, when it is subjected to polarization in any electrolyte, this magnesium alloys, we can observe this cathodic current to the more decreased side. And also this metal dissolution is more the positive current, more high current. So this shifting, it has shifted from here to this side. So this shifting is creating the problem for the magnesium alloy. Why this is happening is that magnesium alloy undergo dissolution by two-step process, whereas other metals undergo by single-step process. Magnesium, it forms an electrochemical intermediate of Mg+ ion. Again, this metal ion react with water and form magnesium 2+ ion. So it is taking, it is releasing excess of electrons. So those electrons are taken up by the H+ ion, and so the hydrogen evolution is very high. And also it increases every time each steps to metal ion is used, magnesium ion is used. So it doubles the amount of dissolution also. So the magnesium is undergoing the following this negative difference effect. So another next. So another problem is that magnesium alloys are having the intermetallic, it forms the intermetallic particle during the preparation of the process. So generally if we take AZ magnesium alloys, it forms alpha pure magnesium phase and also the beta intermetallic phase of Mg17Al12. When these are coming into contact with any of the solution, just next. So when it is coming into contact with any of the electrolyte solution, the surface area comes into effect. So the alpha phase acts as the anode and smaller beta phase acts as the cathode. So the galvanic couple forms and immediately it undergoes the corrosion. Mainly it undergoes internal galvanic corrosion or microgalvanic corrosion. Also some of the foreign elements like iron, copper and manganese which are introduced into the alloy during the preparation process also act as leads to this type of internal galvanic corrosion for magnesium alloys. So next. So the heading is getting cut, I don't know. So when we are seeing what are the methods for prevention of this corrosion of the magnesium alloy is that several methods are available. The most effective one is the formation of the protective coatings over the magnesium alloy. So if you see the patents, there are several patents are available on this, and China has patented patented a large number of patents on magnesium alloys. when compared to the other countries. We can see there is no place, India is not seen in the graph at all. So next. And if you see the patterns, what is the heading is, sorry, excuse me. Hello.
Ma'am?
This, I think heading, it is getting cut. I don't know.
Yes, ma'am. We will rectify, ma'am.
So I can continue like that, or?
Yes, ma'am. You can continue, ma'am. We will rectify it within a minute.
Yeah, thank you very much. Actually, if you see the patents available on the protective coatings developed on magnesium alloys, the conversion coatings are most widely patented, and it is around 41% when compared to the other coating types. So the conversion coating is nothing but the conversion of the substrate surface by chemical and electrochemical methods. So next. Hello. Next slide. Next.
Ma'am, slightly we have a technical issue, ma'am.
Yeah, no problem.
Just
I will wait, no problem.
Okay. Yes, ma'am.
If we see the coating systems, these micro-arc oxidation coatings are recently considered as the most promising coating system for magnesium alloy to improve the corrosion resistance property. So micro-arc oxidation is nothing but the electrochemical conversion coating process, that is anodization process carried out at a higher voltage. So it is normally a simple setup is used for development of this coating. Here we anode the working, whatever the substrate we are using act as the anode, and the stainless steel cathode is used, and alkaline electrolyte is used. And they are connected with the power supply. So this here one important thing is this anode undergo dissolution and it forms a oxide coating in the presence of alkaline electrolyte solution. So highly alkaline solution, it leads to formation of thick oxide over the magnesium surface. So this is the schematic representation of this MAO coating, where the substrate is getting dissolved and form a thick barrier oxide layer, which is very thin barrier dense barrier oxide layer, and followed by a thick porous layer, oxide layer. So this coating generally develops around even more than 100 micron thickness. So next. So we can see some of the applications of this micro-arc oxidation coating here. here mainly used for engine pistons and aluminum alloy applications, and also mainly wheel hubs are nowadays made from this micro oxidation method. Also mobile phone shells are nowadays done with the MAO process. So generally the highly alkaline solution is used, electrolyte solution is used for developing this coating. And since the substrate itself is modified in the electrolyte medium, so it can develop adherent ceramic oxide coatings with higher hardness and good corrosion and wear resistance property, and also good dielectric property. So next. So coming to the preparation of this MAO coating, here we have used AZ31B magnesium alloy. Actually, this is the alloy secondary structural, it is the alloy used for secondary structural applications, and it is having the good strength and medium corrosion resistance property. So it is first the sample, this is optional one, mechanical grinding can be done, and then it is ultrasonicated with acetone for some 15 minutes. And then it can be the micro oxidation coating can be developed. So the bath composition we have used is sodium silicate bath and with fluorine and hydroxide, potassium hydroxide. And the pH of the bath is around 11. And we have carried out this coatings at 3 different current densities. It's around 20 milliamps, 40 and 60 milliamps. So the temperature should be maintained below 45 degrees. So next. So this is the setup just we have used for developing this coating. Generally here we have not done grinding or just any mechanical grinding on the surface. Directly we have used a sample. So, and then we have used a high voltage power supply of 1000 volt and 12 amps. And it is connected with the chiller system. And during the process, the spark will be seen over the surface. That is, the plasma is created during the MAO process. Next. So during this coating process, the voltage versus time response is recorded. And in it, we can see 3 different zones. First, there is the active increase in the current. There is a drastic increase, steep increase in the current. Voltage is observed. This is due to the anodization process. During this time, the barrier layer is formed. After that, over the barrier layer, there is some weak points will be there. So the current will be concentrating at the weaker points and break the oxide layer, and the sparks will be initiated. So once the spark is initiated, this process will be continuous in different places. So during the presence of the spark, the metal undergo dissolution, and then it is dissolution and it from the surface. So, but the electrolyte present surrounding the metal ion will be cooling that metal ion, and it can get redeposited on the substrate itself. So the dissolution and redeposition takes place continuously, leading to the fluctuation in the voltage. There is a decrease and increase. A lot of fluctuation is observed in this region. So the steady plasma is generated, which increases the thickness of the oxide layer. So we can build up to 100 to 200 micron thickness for this coating. So with that, we can see this breakdown voltage increases with increase in current density. Next. So this is the surface morphology we can see through SEM, that we have different current density. At lower current density, the pore density is very high. As the current increases, the diameter of the pore increases. And also we can see the cracks over the surface. So these cracks are formed due to the releasing of the thermal stress created during the coating formation. Next. So this is the backscattering electron mode. Images were captured. This is like we can confirm here the pores we have seen on the surface is not a continuous pores. They are very deep pores. They are very shallow pores, and they are not continuous, and they are discontinuous also. So the diameter of the pore increases with increase in the current density. Next. So the EDAX is carried out to check the composition of the coatings. So the oxygen content increases oxygen and magnesium content increases with increase in current density, and shows that magnesium oxide layer is formed over the surface. Whereas the fluoride and silica content decreased with current density, and this could be due to the interaction between the silica and fluoride that takes place at the interface and forming silicon SiF4. Next. So we have prepared a cross-section sample to check the how the pores are oriented. So we could observe that at the current density, it is very surprising result also. This 40 amps per centimeter square, milliamps per centimeter square, it showed a very dense coating. So the coating is very dense, and also the thickness is very high. It is up to, in 15 minutes, we are able to achieve up to 12 micron thickness. So whereas the other two this lowest and this highest current density, it is the coating is porous, and the current and thickness is also less. So this we can confirm that the pores that formed are not continuous pores. It is a discontinuous pores, and it is not reaching the substrate material. Next. So coming to the electrochemical studies, this is the electrochemical workstation we have used, and it is Autolab PGStat 30 instrument. And this we have used 3 electrode cells, and these experiments were carried out in 3.5% of NaCl solution. And we have used the working electrode is the test specimen, and counter electrode is platinum stripe, and the reference electrode is saturated calomel electrode. So next. So generally the electrochemical techniques, these are the techniques, several techniques are used for the evaluation of this coating, which is the DC and AC method. Here the techniques are the OCP versus time, which is carried out under equilibrium condition, Tafel plot, potential dynamic or anodic polarization plot, electrochemical noise measurements, electrochemical impedance spectroscopy, and dynamic electrochemical impedance spectroscopy methods. So we are, based on our requirements, we'll be using these techniques to evaluate our coating. Next. Coming to the first thing is the open circuit potential versus time plot. Actually, when any sample is immersed into the electrolyte, it undergoes a continuous oxidation and reduction process. So then after that, it reaches certain equilibrium potential. So these measurements of this potential is carried out in the absence of current. The more potential potential created will be monitored with the time, and it is recorded with respect to the reference electrode. So this is the OCP versus time plot obtained for magnesium AZ31B magnesium alloy in 3.5% of NaCl medium. Initially, there was an active steep increase in the voltage due to oxidation and reduction process. Afterwards, there is it become passive. It becomes stable due to the formation of the passive oxide layer over the surface. So just I have used one more example just to also for clarity. Here we can also check that how the coatings, barrier type of coatings can behave with the magnesium alloy in the open circuit potential condition. So we can see the magnesium is around minus 1.5 volt, whereas this barrier type of coatings shows more positive potential of minus around 0.10 and minus 5. So it indicates more barrier coatings are more stable in the corrosive environment when compared to the substrate material. Next. So generally after attaining the open circuit potential, we'll be calculating, we are doing the Tafel, we are doing the Tafel plot. Just to this Tafel plot help us to determine the rate of the electrochemical reaction. It is nothing but just we are calculating the current, that measuring the current and also the potential. And we can also calculate the resistance of the coating. So this after attaining the open circuit potential, the sample is polarized cathodic and anodically 200 millivolts using linear sweep voltammetry. from its open circuit potential. Then it will be carried out at the sweep rate of 1 millivolt per second. So we will be getting this kind normally in typical metal, for the typical coating. Generally, we will be getting this kind of taffel plot. So it is very symmetrical, and here we can see the anodic. There is due to the metal dissolution process, the anodic branch is formed, and due to the hydrogen evolution process, the cathodic branch is formed. So here, for determining the current, we need the taffel slope values as per this equation, Stan-Gary equation. So we are fixing from the open circuit potential 60 millivolts to 120 millivolts, and just we are taking 2 points and we are drawing the line. So we get the taffel slopes. So where these taffels in both the branches, where it intersects these points will give the corrosion potential and corrosion current. So this is the typical taffel slope obtained for getting for any metals. Next. But in the case of magnesium alloy, we are not getting these type of any taffel region at all in the anodic side due to the negative difference effect. So we cannot get the symmetrical anodic and cathodic branches. So it is not able, we cannot analyze this by this taffel extrapolation method. So it is that we will be taking only the current value and we can analyze the data. Just for clarity, I have given the barrier nickel phosphorus coating. So it is in the it is forming a symmetrical taffel region. So it is very much possible to draw a line and find extrapolate it and get the current value. So the current, when current decreases, the resistance value increases as per the Ohm's law. So we are getting the corrosion current value. So when compared to the substrate material, this coating we're having 2 order magnitude lower corrosion current, indicates that the resistance of the better resistance of the coating. So next. So is coming back to the micro-oxidation coating, we have carried out potentiodynamic and anodic polarization studies, because as we have seen that magnesium doesn't follow the taffel, it is very difficult to analyze through taffel plot since it is not having the taffel region at all. So we have carried out, we have not just done taffel plot, we have done the anodic polarization study also to understand the anodic behavior of the magnesium alloy. So this is the plot. Here we can see that magnesium alloys are at around 10 power minus 4, whereas the coating are very much lower current. So the coating developed at 40 milliamps per centimeter square has showed drastic decrease around 6 order magnitude lower, indicate the good corrosion resistance of this coating. So we can correlate the microstructure with the corrosion behavior. Here the coating is very dense, so we are able to achieve very good corrosion resistance, and this is value is the first we have seen for magnesium alloys. So low corrosion current is not reported generally for magnesium alloys. So we claim that this coating developed at 40 milliamps per centimeter square is having excellent corrosion resistance behavior. Also, it is showing a passivation behavior, and it also follows the taffel plot. So next. So these are the data we have obtained by fitting this plot. So here we can see this. The 40 milliamps, the coating, 40 milliamps coatings shows very low corrosion current of 7.79 into 10 to the power of minus 9, whereas there is when compared to the other coating. But here the magnesium alloy is showing around 10 power minus 4. So there is a drastic decrease in the current, and it is around 6 order magnitude of improvement in the corrosion resistance. So the corrosion rate is also very low. It is around 4.8 into 10 to the power of minus So it exhibits excellent corrosion resistance. So next. So we have just till now using the DC methods, we have understood that we have calculated the corrosion rate of the coatings coatings whatever we have developed. But here we can use the electrochemical impedance spectroscopy, which is the AC techniques, to understand what type of corrosion mechanism is taking place, along with the calculating the resistance of the coating. We can so the electrochemical impedance spectroscopy involves the excitation of the electrochemical system by small amplitude of AC signal and measuring the current response over the wide range of wide frequency range. So it is a non-destructive method. It uses very small amplitude of 5 to 10 millivolt and wide range of frequency around 10 microhertz to 100 megahertz are used. So we can measure over a long frequency range, but generally for coating, we are using 10 millihertz to 1 kilohertz. It is the fast acquisition of data is possible, and it provides the data about the resistance, capacitance, and inductance of the system. So we are able to understand the corrosion mechanism. So it is a very fantastic tool to understand the corrosion mechanism of taking place between the substrate and the electrolyte and the coatings. So these data are displayed as Nyquist and the Bode plot. Nyquist plot is the plot of real and imaginary impedance, whereas the Bode plot is the plot of impedance modules versus frequency and on phase angle versus frequency. So this is the typical Nyquist plot reported in the literature. Generally, the diameter of the lower frequency, high frequency region is related with the solution resistance, whereas lower frequency is related with the charge transfer resistance. And we can obtain the capacitance value at the maximum frequency. So it is mainly related with the diameter of the semicircle. The resistance is directly related with the diameter of the semicircle. Larger the diameter, better the corrosion resistances. So these can be correlated with the equivalent circuits having the resistance and capacitor, that is having the time constants. So next. So this is the polarization plot, EAS plot, Nyquist and Bode plot obtained for the MAO coatings that prepared at different current density. We can see this the coatings prepared at 40 milliamps exhibited larger diameter of circle, indicates that better corrosion resistance. So when we can observe at lower frequency there is two semicircles, one at lower frequency, high frequency region, and other at the lower frequency region. So this can be clearly seen from the Bode plot also, showing the phase angle. Phase angle shows the two peaks, and the resistance of this, the absolute resistance of this coating is very high when compared to other. So this also clearly indicates this the coating is exhibited excellent corrosion resistance property, and the phase angle values varied from 70 to 80 degrees. So next. So actually from the plot, what is the mechanism we can arrive is that it is fitted with the equivalent circuits having two time constant. One is related with the barrier layer, resistance and capacitance of the barrier layer, and the next one is related with the porous and related with the porous layer. So the solution, this is the solution resistance. First the solution enter into the porous layer, so then it reaches the barrier layer. So, but the barrier layer is very dense. So though it is having 1 micron thickness or less than that, it is very dense. So it doesn't allow the electrolyte to attack the substrate material. So it is increasing the resistance of the coating. So after using this equivalent circuit, we have fitted the data, and these EAS data are obtained. So we get the resistance through the porous resistance and also barrier layer resistance. So together, if we see the total resistance of the coating is around 3.36 meha ohms. So this value we can correlate with the polarization resistance obtained from the potential from the TAF anodic plot or polarization plot. So almost they are in the same range. So that so we can understand the by EAS we can understand the mechanism of the coating, and also we can calculate the resistance of the coating. Next. So generally, potential dynamic polarization and EAS are most extensively used for calculating the corrosion resistance of the coating. So one new, not new, just it is one more technique which is the will give supporting information for our studies is that electrochemical noise measurement. It is noise measurement, ENM, electrochemical noise measurement is monitoring the fluctuation, that noise of potential and current that occur at the electrode-electrolyte interface as a function of time. So the noise resistance is calculated from the potential standard deviation by current standard deviation. Generally, for this is the setup used for this to measure this noise resistance. 2 working electrode is used. It should be of same dimension and same type. So it is these 2 are connected with the potentiostat along with the reference electrode. So the current is calculated between current noise is calculated between obtained from this substrates and the working electrode and the potential noise is obtained from the reference electrodes. So this is a more this measurement is also non-destructive method because it is just like OCP. We are connecting the system and monitoring the noise in the current and the potential. So it is a non-destructive method and fast acquisition of data is possible. And it is it can be data can be acquired with the time and frequency domain. Next. So this is a noise data obtained for the MAO coating. Here I can say here, this is the coating prepared at 40 milliamps. So when 1 hour of immersion, when we have done carried out 1 hour immersion, so we observed there is no noise. Noise is seen in the curve, but after 96 hours of immersion, the lot of fluctuation is observed in the current, and also the pits were formed over the surface. So also in the if we see that the coating prepared at 60 milliamps, there is up to 1 hour there is no problem. After 96 hours, the pit is initiated. So we have discarded these samples after 96 hours. But whereas this coating, the coating prepared at 40 milliamps, which is very dense, it does not show any fluctuation up to 96 hours. And we have also enlarged that here. We can see the current, what current we observed is around 10 power minus 5 into 10 to the power of minus 10. The similar current we observed in our that potentiodynamic polarization study. So there is no, we can correlate this and understand the behavior of the coating. So there is no fluctuation. It is around 10 to the power of minus 9. After 336 hours, there is a fluctuation is observed. But since we have not observed any pits over the surface, but since the other 2 samples are discarded, we have stopped the experiment. So it is very good supporting informations that we are getting from the for these coatings. Next. So this is the current noise we have observed for this. Sorry, something potential noise. Actually, it comes like current noise. So potential noise we have observed for this coating from using the potential noise, standard deviation of potential noise and the current noise. We have calculated the noise resistance value. So at 1 hour of immersion, we are able to observe 34.8 megaohms. All resistance are in megaohms. After 36 and 96, these samples failed, and it is around kilo ohms. Whereas this coating after 336 hours, it showed 1.5 kilo ohms. So it indicates this coating, especially, it is more surprising research work that we have carried out. It is showing very good corrosion resistance throughout the study. Whatever, at any time the sample is prepared and whatever is the study is made, it retain its the protection resistance behavior. So next. So to understand the generally we have to understand like normally when any electro coatings or substrate is immersed into the electrolyte, it will be forming a double layer. That is nothing but it acts as a capacitance. So in order, we have curiosity to study the semiconducting behavior of these coatings. So we have carried out dynamic electrochemical impedance spectroscopy. Just I have not given any much detail about that, but it is nothing but we have to select certain potentials. Whatever the certain potential, or from potential dynamic polarization plot, we have selected the potential, and we have applied on the electrochemical impedance spectroscopy EAS method. So continuously each potential, the EAS plots were generated, and after this, from the plots, the capacitance values were calculated. So we have applied that values for this calculating the used for Mott-Schottky analysis to understand the capacitive nature of the coating, nothing but semiconductor property of the coating. Actually, this is out of our curiosity we have done this. So next. From the plot Mott-Schottky analysis, we are able to see that the magnesium alloys, AZ31B magnesium alloys show the positive slope, whereas all other coatings showed negative slopes. So this is clearly shows that this magnesium exhibit N-type semiconductor property, whereas the coating exhibited P-type semiconductor property. So it is due to that the magnesium alloys will have due to the dissolution, it have a lot of cationic vacancies, and so it is exhibiting the N-type semiconductor property. Whereas this in the case of coatings, there is a large accumulation of OH and anionic species over the surface, and a surface and metal dissolution is less, so it is existing the anionic P-type semiconducting property. Whereas for this coating developed at 40 milliamps, it exhibited the higher acceptor density value of 9.6 into 10 to the power of minus 30. So this is next. So I am summarizing like the magnesium, the micro-arc oxidation coatings are most promising coating for the corrosion protection of magnesium alloy. And these electrochemical techniques are very much useful for understanding the corrosion mechanism. So there are several techniques are available, and the data of each techniques can be related with one another, and we can get very good and very useful information for our research purpose. Next. I acknowledge our director and Professor Subramaniam from Indian Institute of Science, Bangalore, and head of our BND NPL and SCD NAL, and Dr. J.N. Balaraju, and our team members in NAL and NPL, and my research students in NPL. And also, I thank the organizers of ICAMS for giving me this nice opportunity to share my research experience on magnesium alloy with the here in the good platform. So thank you. Next.
Thank you, ma'am. Thank you so much for giving a splendid performance.
Thank you. Thank
Your
you.
lectures will give us lot of informations. All are informative and knowledgeable. I think all the participants will gain lot of messages from your performance, and the PhD scholars and research students, they gain lot of knowledge for their PhD. For their
Really,
thesis.
actually speaking, I've given different each EA electrochemical impedance spectroscopy separate talk in some different places and all those things. But these tools are very much useful for them to get good information about. With one sample, they can do many experiments and get more information, and it will be very much useful for the research students. Mainly, I gave this talk for research students only.
Yes, ma'am. Yes, ma'am. This is very much useful to them. ma'am.
Very simple instrument also will give many informations, but we have to understand and do it. So you can finish
Okay.
your PhD very nicely.
Yeah.
Thank you.
Okay,
Thank you
ma'am.
very much.
Thank you so much, ma'am, for sparing time with us, even in your busy schedule. Thank you so much, ma'am. Reciprocation is the way of judging the program. I request the participant to reciprocate with our chief guest, Dr. Elichal, ma'am. You can ask your questions, or you can give a suggestion or compliments. This is the time for question session. I request the participants to raise your questions to ma'am. Dear participants, if you have any doubt, any queries, you can ask to Okay. Thank you all the participants. Then I have one more information. In the chat box, we have sent you the feedback form, feedback link. You can fill the feedback for the session, afternoon session. We have 4 sessions. Tomorrow we have 2 sessions. All the participants for conducting today's session, and I thank your patience from morning to till now. Once again, I thank our chairperson, Dr. Elichal ma'am, for sparing time with us. Thank you for all of you. You can come tomorrow. The session will start on 10:30. So you can join in 10 minutes advance. Thank you so much. Thank you for all of you. Yes, we can leave the session. The today's session's program is over to now. You can have a tomorrow session. The program. It will start 10:30. You can join earlier 10 minutes, 15 minutes earlier. 10:15 or 10:20. Thank you all the participants. Now the session is over now. Tomorrow is 10:30. I request all the participants, you can leave now.